Hey everyone, this is Anshul Sadaria, Software Engineer 3 at Google. I have a question for all of you. How many of you have used dating applications like Tinder, Bumble, and I don't know what all other names are there? I already feel old. Don't lie to me, I can already see your smirks behind the screens. So, did you know that the initial name of Tinder was Matchbox? Obviously because of the pun. Match because it was meant to match different people, and Matchbox because it was igniting new sparks. No, this video is not about me sharing some fun facts about dating applications, but a rather interesting system design. Yes, we are going to do a system design for dating applications. So if I use Tinder, Bumble, dating applications or dating sites, don't be confused, we are going to talk about the same thing. But before we jump into the video, if you want to keep learning from industry-leading experts, do check out Scalar's free masterclasses on Scalar's event page. Link is in the description below. So let's get started. So what are the prerequisites that you should keep in mind before you watch this video or continue watching this video? Absolutely nothing, because this video is meant for you to learn new stuff. We'll be discussing new design strategies and so on. But if you want to get the most out of this video, I would really recommend if you understand some of the computer science fundamentals. Okay, when I talk about computer science fundamentals, I mean networking, databases, DBMS, and so on. You should understand what are the pros and cons of a choice of one database over the other. And you will also definitely hear some technical jargon here and there. So if you hear some technical jargon, don't worry, make sure you note it down. And I would really love if you search it over the web. Even if you don't understand, don't feel scared. Ask me in the comment section. I will be very happy to resolve any doubt of yours. This video is going to be like a roller coaster, but make sure you keep your eyes open. You will feel excited, there will be some thrill, and you will feel scared at some moments as well. But don't worry, as long as you have that learning attitude. Now the first step before you jump into the system design is to make sure you don't actually jump into the system design. Make sure you prepare the requirements, like what all things you should add in your system, what all features should be added to the system, and then only post the decision of requirements, jump into the design choices like what databases you want to use, how the data should be modeled, and so on. But this is my preference. There are two schools of thoughts regarding this. One is the bottom-up approach, where they decide the ER model, the entity relationship model, what data will be stored, how it will be stored. Then they decide how the services, what services will consume the data. On top of that, they will decide how the client or the user will interact with these services. Personally, I don't prefer this approach, and this is my personal opinion. I'm repeating again. My personal preference is a top-down approach where we create the feature requirements. Then we decide what all services are required to make sure that these feature requirements are complete. On bottom of that, we will decide what data will be stored, how it will be stored, and then prepare a ER model based upon the services and what they will consume. So we are going to use a top-down approach in this system design video. And the primary reason I love this approach is because once the requirements are locked, the design decisions become a lot simpler. If you want to understand the real power of requirements, do check out my video on Twitter system design. Now, how about you tell me in the comment section what all requirements you would have decided if you were designing Tinder or any other dating application. For the sake of clarity, I am going to categorize the features or the requirements into two categories: functional requirements and non-functional ones. Now, functional requirements are the ones which actually influence the journey of a user, like how the user will interact with what all features. Now, let's go step by step to understand what a customer journey will look like. First of all, a customer would want to create their profile or register onto the dating site. So let's change the color, create profile. Okay, pardon my handwriting because I know it's really bad. I have not written for a very long time. So we will create a profile. Next, I would really want to update my profile as and when required. For example, if I got promoted, I would want to mention that thing, I would want to update my profile. So the user should be given an option to update. Okay, I'm not going to write entire update profile. So post that, what all things does a user actually do? If I remember my journey when I was like exploring dating sites, so I would want to set my preferences, yes, definitely. Like what age range am I looking for? For example, I'm 24 right now. So I might prefer people who are in the age range of 20 to 24, 25 something, I guess. And what all gender orientation I'm looking for, male, female, or any other non-binary gender orientation. So my preference would be female. And then I would have some location preferences as well. Like, do I want to connect with females in the radius of 10 miles or 15 miles, or what am I looking for? So we should definitely be able to set preferences. Okay, I'm not going to write this complete again. We should be able to set preferences, and further down in this video, we will understand how these preferences will actually influence the recommendation service. Okay, I'm not going to reveal a lot of details because that will be covered down the lane in the video. Now we have set the preferences, our profile is ready. What's the next part? Swipe left or swipe right. So the user should be able to swipe and post, like swiping left and right. Let's say you swiped right on someone and then someone swiped right on you as well, like the same person swiped right on you. So you both have matched. Okay, now you should be allowed to chat with each other. So we should be given a possibility or a feature to chat with each other once we have matched with different people. This is what I feel should be our functional requirements. Do you think there should be more functional requirements which we should consider? Let me think about it. Oh yeah, definitely. Like we would want to upload some images, right? Because from my experience, we don't usually look at what the person has written in the profile. We usually judge the people based on their appearances, unfortunately, but that's the harsh truth. So I should, this functional requirement should come on the top, but upload pics, yeah, again, ignore my handwriting. So we should be given a preference to upload pics, and we will decide in this video, like we will make some design discussions, like what data store should we use, whether we should use a data store or not. So I think this functional requirements should be sufficient to get started with designing our system of Tinder or Bumble. Let me know if you think otherwise, because I remember from my experience, there are some other cool features as well, like you should be able to super like a profile, or you should be able to see the likes, like which profiles have liked you, and then you should be allowed to rewind the profile, like in case you left swiped someone and you want to rewind the profile and like them again, or even like if you want to see their profile. So that should be a possible feature. But as far as I remember, these features are available only for premium users, so we can possibly ignore it. These are not really important for us to create our MVP application, like the minimum viable product. These are not very important features. So we can now jump onto the functional requirements and lock them. Now let's jump into the non-functional requirements. First of all, what are non-functional requirements? These requirements don't necessarily influence the user's journey, but rather it affects the user experience. Let's say our system should be highly available. Like it should not happen that I'm not able to use the application for a really long time, right? Then the system should be consistent, because if someone is updating their profile, I should get that information over the time. Okay, now let me know in the comments, what do you think? Should the consistency be eventual consistency or strong consistency? What does eventual consistency mean? Like after some time, the information is propagated to you ultimately. What strong consistency means is that the moment the information is updated, at the same moment, the information should be propagated to all the nodes. I really feel that strong consistency must be very harsh for an application like this. Let's say some person updated their profile info or uploaded new pictures. It's fine for me as a user if I'm not seeing their updated pictures at the same time. Eventually, I will get their updated profile info. So I don't think there is a requirement to push too hard for strong consistency. Let me know if you think otherwise. Then minimal latency is really important for applications like this. Minimum latency. because it would be a really bad user experience if I'm scrolling at a profile and I'm not able to see their pictures, or if I'm doing a left swipe and I'm not able to see the new profile really quickly. So highly available, consistent, minimum latency. What all other non-functional requirements do you think this application or dating site should support? Let me know in the comments below, because I have deliberately missed out on some of them, which I will talk about in the video further. Having decided our requirements, now it's time to decide what all services will fulfill those requirements. So let's move on to that part. First of all, it should be the profile service. Okay. Now, if you look on our requirements, the profile service should handle the logic for create profile, update profile, set preferences, right? And yeah, obviously, definitely, like upload pics should also be handled by our profile service. Next should be the swipe service, possibly, because the user should be able to swipe. Now, if you look at our requirements, the swipe functionality should be like made available through this service, and also the logic behind, like when two person right swipe onto each other, they should match with each other. So this logic should also be handled by the swipe service. Now, if you notice one thing, we missed upon a crucial functional requirement, which was recommendation. Something happens behind the curtains. Like the user doesn't see the recommendation service working, but the application, the system does work on some recommendations based on the user preferences that you had set while you are creating your profile. So recommendation service is something which works behind the screen, and this should make sure that we get the profiles that we are looking for. Like the purpose of the recommendation system or the recommendation service is to show us the profiles which we are most likely to right swipe on. So that logic will be handled by this service. And lastly, the chat service, because when two people match with each other, they would want to chat with each other. For this particular service, I would really love if you have some background about networking or some communication protocols. Don't worry if you don't know, we will discuss them in detail as well. But I would really love if you do some homework before we jump onto the chat service portion. So now let's jump directly into our profile service designing. We will be having a lot of healthy discussion regarding some of the design choices that we'll make as a part of this profile service. So let's move. Okay, we already designed the services. So profile service, first of all, there will be a client. I think my handwriting is improving over the time. Then we will have a profile service. Okay, so the first thing that the client will want to do is to create a profile. They will pass in the username and the password, and this information will be stored in a database over here. So yeah, we can use a SQL database, we can create cache over it. Those all are the stuff that I'm not going to go deeper into, because I have already explained how you can use cache and all of those stuff in one of my previous videos where I talked about the system design of Twitter. So do take a look at it to understand how we can reduce the query time and all those stuff using the caching services. So we will create the profile. The profile service will be capable of doing that. Now let's say we want to update a user profile. So let's remove this part. Okay. Now let's say we want to update it. Okay. So we will pass in the user ID and the info that we want to update. Now if you take a look at this, there is no way of authenticating. Like how does the system know, or how does the profile service know that the user ID whose information I want to update is my own? So we will like need to pass in the password or some sort of thing like that along with this. And here there will be some authentication system which will check if like the user ID that I have passed in is actually my user ID. Now I forgot to tell you some things, like if you actually use a dating application, you will see there are a lot of other authentication mechanisms, like you can log in through Google, you can log in through Facebook and so on. So there are some external authentication services which you can use. For two-factor authentication, if you have used, like your OTP goes to your mobile phone and then you pass in that OTP to the application. So there will be an SMS service as well. Okay. But for the sake of clarity, I don't want to add a lot of things to this particular service because it takes away the essence of the stuff that I really want to discuss. Okay. So, okay, we'll reduce the size of the eraser first of all. Yeah. So we'll not dig much deeper into the external authentication mechanisms or the SMS service. Let's keep it fluffy, let's keep it natural. Now, a healthy practice is not to store the password directly into the databases. So instead of password, what I would prefer is to use something known as tokens. So tokens is very common in the authentication mechanisms. I'm not going to go deep into the cryptography and all of that. So let's take away that portion away. Tokens. So the actual implementation happens through something known as JWT, which is known as JSON Web Token. Again, I'm not going to digress away from this topic by going deep into what JWT actually means. So we are going to use tokens for the authentication purpose. Now, let's assume there is some other service. Let's say there is chat service. Chat service wants to know if you are the user ID who wants to communicate with their match. So they will want to interact with the profile service because the authentication module or the authentication mechanism is a part of the profile service. Let's say chat service is fine. Let's say we add a few more services as well. We don't want to repeat the logic. We don't want to interact. We don't want all of these services to interact with the profile service. That takes away the entire essence of microservices because microservices are meant to handle a particular logic. If all the services are interacting with the profile service, it's not a good design system. So we will modify the architecture a little bit. Let's keep a profile service over here. And in front of the profile service, we will have something known as a routing mechanism, or as some people love to call it, gateway service. Okay. So the gateway service will handle the requests coming from the client and then route it to a particular service. It can be profile service, chat service, swipe service, recommendation service, or anything. Okay. This is a very neat design. You know why? Let me know in the comments. But otherwise, I think it's a very neat design because it abstracts or encapsulates all of the services. The client doesn't need to interact with individual services. The client just needs to interact with the gateway and no other service will interact with the client. Only the communication will happen between the client and the gateway service. That's the beauty of it. So this gateway will be responsible for communicating with different services. Now, having designed the high-level infrastructure or the system design of profile service, let's take a look at how we are going to model the data. We are going to design the SQL table for the user. For that, we will have user ID as the primary key. We will store age, preference, location, and other details related to the user. Now, the important question which I want to ask all of the viewers is, where should we store the images? Because if you remember, the profile service handles the logic of uploading image or updating image and so on. So how should we store the images? Should we store it in the same table? Like should we store image 1, image 2 and so on? Or perhaps we can create a more normalized version of the table. Like we can create a new partition, a new table which will store images. We will have user ID, we will have image ID, and we will have the image over here. And instead of storing the image in this user table, we can have an image table where we will store the image ID instead of the entire image in the user table. I think the later one is a more flexible opinion. It keeps the user table a bit lighter. But one issue that can come up with this design is that it might require multiple lookups. Like for example, if a user wants to see the profile image of a particular user, we will need multiple lookups. We will query the user table, then the user table will query the image table and then return the image. It can be a little heavy, it can be very expensive operation. So we will decide how we can work upon this particular question of where to store the images. Should we store in the same data store, or we can store it in the form of a distributed file system and so on. Don't worry if you don't understand the technical jargon. We will discuss the pros and cons of each of these approaches, and then we will make a call what system we are going to use for our dating application. Now, the question that was really important, which I wanted to emphasize on, how are we going to store the images? Now, we considered two approaches in the previous slide, storing it in the same data store. It will be in the form of blobs. Now, to those who don't understand what blob is, it stands for binary large object. It's just zeros and ones, like the image is stored in the form of binary large object, which is zeros and ones. In the same data store, we have two choices. Either we can store the entire image, all the 5 images, in the same user table, or we can store it in the different image table and then create a reference in the user table for that. Another option is file system. Now, before we take a call of our preference between both of them, it's important to understand the pros and cons of each of these choices. Now let's see what does the data store have to offer us. The first thing is transactions. These are the atomicity, like the database provides us the atomic structure, all the transactions happen in one go together. Then it's the mutability. It allows us to update the images, delete the images, update a part of image, and so on. Do we actually require this? We are going to discuss this further. Then it provides us an opportunity to index. This is usually used for search operations. We are not going to search over the images. So this particular offering may also not be required for us to store the images. And the last one, which is a very important one, which I want to highlight, is security or the access controls. Like the same security offering which is provided to the user data, the same offering is provided to the images as well, which is a pro of storing it in the data store, same data store. Now, as we discussed, we don't need the indexing offering because we are not going to search on a portion of an image, or we are not even going to search on the basis of image. We are going to search possibly based on the age range or any of the user preferences that we have set. So indexes are not actually required to store the images. Mutability is important because we are going to update the images, but we can do one thing, like we can create a new image, we can create a new file and then delete the old one. So in this way, we don't actually use the mutability feature of the data store. We are not going to update some part of the image. So that is also not required. Now transactions, atomicity is also not required because we can update the image or delete the image asynchronously. It doesn't need to happen in a single transaction. So we can get rid of this as well. Security is important, but we will see how we can manage security in our file system as well if such a possibility arises. Here we discuss the pros of using a data store. Now let's talk about some of the cons which might influence our design choice. So the first con is that multiple lookups, which we already discussed before. So this can be actually an expensive operation, like if we are going to query the images from the data store and send it to the client from a SQL database. So this is going to be very expensive, which is a very important con which we need to consider while making our design choice. The second con is disk IOs take a lot of time. Okay, the image, if the image is very large, it's going to be stored into multiple blocks within the disk. Those who don't understand what I just said, take a course on the databases or database management systems, which will help you understand how the image is stored into blocks which are a part of a disk system. So when you query multiple disks, if your image is stored in multiple disks, you need to query different blocks from the disk. And querying different blocks from the disk is a very expensive operation. If you remember, disk IOs are really expensive. We cannot afford multiple disk IOs for the lookup operation. So this is part of multiple lookups only. and this will also influence our design choice. Now the next thing to remember is a data store creates some replicas. When you create a replica, let's say you are storing image. A user has 5 images and let's say each of them cost 2 MB to us. Now let's say there are millions of users. Can you calculate for me and tell me how much space will be utilized to create a replica? And just imagine how much time will it take to create such a big replica. Replicas are also costly. Let me know in the comment section after you perform the calculation. 2 MB image, 5 images, and million users. Okay, here we are talking about the active users. There can be more than million users. So all of these cons really influence our design choice. Now let's take a look at some of the pros which are offered to us by the file system. We can create a CDN. Okay, I will explain what CDN means, but let's say we have a distributed file system. We can create a CDN on top of it. This is known as content delivery network, which helps us to cache the images if a user is going to query them multiple times. So this actually makes the lookups much faster as compared to data stores, where caching the images will also be very costly because we are storing the images in the data store. We are also storing them in the caches. So it's really expensive for us. As a part of DFS, we are going to store them as in the form of file system. We will store the file URLs along with the user info. Let's see how it looks in our data store. We will have user ID. We will have image ID, and then we will store the file URL. Now, this image ID will be stored in our user table, and from that we will reference the images. So if you want to delete an image or update an image, create a new file and then delete the old file. Yes, it may create some issues of dangling images wherein we are not actually referencing a deleted image and we forgot to delete that image. So we really need to make sure that our mechanisms are in place so that all of the advantages of a data store are actually fulfilled by a file system. Yes, it can be a little bit tedious, but it is still manageable. So I think a distributed file system is the right choice for us to store the images, and let's see how our ultimate profile service will look like. Now, I really believe that we can create a new service, we can spawn a new service to handle all the image operations, because if we store all of these operations inside the profile service, it will be very costly. Let's say there is a new possibility where we can use the images in our machine learning model to, let's say, calculate the beauty of a picture or something, some way to recommend a better suggestion, better profile to the user. Then we will require to query the images. So for this, we can create a new service. Again, there is no hard yes or no, it's my personal preference. We can create a new service, which is the image service, and let this handle all the image related operations. So there will be a distributed file system over here, which it will interact with, and then we'll create a database where it will store the file URL, image ID, and the user ID, and this will be referenced. Whenever someone wants to query the images, the gateway service will reference from the image service instead of the profile service. So it may require 2 calls to the profile service and the image service, but I think decoupling them is a healthier option as compared to merging everything in the profile service. Let me know if you think otherwise. We can have a healthy discussion in the comment section. Now we have completed the design of our profile service. We took some rational calls, we made our own personal decisions. It can be right or wrong, it's very subjective. Now let's move to swipe service. So when a user swipes left or right, this swipe service will handle the logic. if you're going to match with a person or not, this service should handle that logic. Now this is a client. Do you think we should store the swipe information with the client itself rather than storing it in the server? Can you let me know what are the cons of this approach? The first con which I can imagine is if I'm storing all of the likes and dislikes with the client, I have no way to identify on my own as a client if I matched with a person or not. I should be communicating with the server to let the server know that, okay, this is my right swipe. Can you let me know if the opposite person has also right swiped me or not? So ultimately, the server should be the source of truth rather than me making the decisions on the client side. So I think it's a very healthy practice to store that information in the server itself. Let's complete this design. This is our gateway service. This is our swipe service. Now, what will be the ER model? What information are we actually going to store in the data store as a part of the swipe service? There can be multiple options. None of them are right or wrong. It's just some decisions that we take based upon the requirements. So what I have decided, or what I am thinking right now, another issue which I think can come up if we are storing the swipes left and right with the client side is that, let's say I uninstall my application. I am going to lose all of my swipes. And with that, I also lost all of my matches. For some reason in the future, if I come back on the application again, there is no way for me to connect with my matches. This can be a really very bad experience for me. So I actually want to store the match information in the data store itself. Let's take a look how we will design our data store. We can keep the information of user IDs, user ID 1, user ID 2, and then we can actually check if 1 liked, 2 liked, and so on. Don't actually name your variables in this way. This is just for the purpose of the video. So make sure that you follow the proper nomenclature whenever you are preparing your ER model. What will happen is when 1 likes the profile of 2, here 1 liked shows true. Okay. Now when 2 also likes 1, it means 2 liked also becomes true. This is a way for us to ensure that, okay, 1 and 2 have matched with each other if both of them have the value true. If one of them have the value false, then it means that one of them have liked but the other one has not liked. Now with this ER model, do you think we are actually storing the information of our left swipes? If 2 users, both of them have left swiped onto each other, do you think we are going to store that information in our ER model? I think we are losing the left swipes, and I don't think it's a very crucial information that we are losing on, because if I'm left swiping a profile and I get the same profile again, and let's say I change my mind for some reason, I should be allowed to have another opportunity or even multiple opportunities in that case to match with that person, or at least right swipe the other profile. So this service will be responsible to let us know if a user 1 has matched with a user 2 or not. This service is going to be consumed by a lot of other services. Can you let me know in the comment section which all services will be consuming this service? If you are looking to chat with your match after you have matched with a person, this service, the chat service, will want to know whether you have matched with user 2 or not, in case you are trying to chat with user 2. You are user 1 in this case. So the chat service will interact with the swipe service to get the information about the match. Now let's say you want to look at the profile of the user 2 who you have matched with. So the profile service will want to know if you are actually allowed to see the profile of user 2 or not. So the profile service will also interact with the match service, and the match service will return a true or false in a Boolean way to let the profile service know that, hey, it's okay for user 1 to see the profile information of user 2. You may just want to look at the likes and dislikes of the person, the interest of the person, or just randomly stalk the profile of your match. Now we have already designed 2 of the services out of the 4. profile service and the swipe service. Which service should we design next? My heart really says recommendation system, but I think it's really complicated to explain it at this moment. So we will keep it for the later and go on to the chat service. Now let's say you are user 1, you match with a user 2 and you want to chat with that user. We also have a user 2. How will both of them communicate with each other? We have gateway over here. User 1 would be like, hey gateway, can you send message to user 2? Gateway would be like, how do I know if you have actually matched with user 2? Remember the swipe service which we just recently designed? Yes, the gateway can directly communicate with the swipe service and then forward the message to user 2. Do you think it actually works in this way? I feel that we should decouple the logic of gateway actually taking the decision whether the message should be sent to user 2 or not. So for that purpose, let us create a new service which will handle all of that logic. So instead of gateway actually communicating with the swipe service, we will let gateway communicate with the chat service and rely on the chat service to ask the swipe service if user 2 and user 1 have actually matched with each other or not. Once the swipe service says that, hey, like user 1 has matched with user 2, allow it to send the message to user 2. But an important thing to remember here, and I really hope you didn't bunk your networking classes because we are going to talk about some of the communication protocols. Okay, let me ask you a quick question. What is HTTP? I'm not asking you for the full form because you obviously know that, Hypertext Transfer Protocol. But what I mean to say is that it's a client-server communication protocol where the client sends the request to the server and the server doesn't ask the client that, hey client, do you want to ask me anything? The server just sends the response to the client. So in this case, do you think that the gateway will actually query the user 2 saying that, hey, this is the message that you have got from user 1? That's not what HTTP does. Here we have a different protocol which is known as XMPP. So obviously we are not going to send the message to user 2 directly. We are going to communicate through the XMPP protocol, which is the peer-to-peer communication protocol. Here there are no differences between client and server. All of them are equal. There is no discrimination between the client or the server. So with this peer-to-peer protocol, the gateway can actually send the message to the user 2. Otherwise, imagine what would have happened. Like if we were communicating over HTTP, user 2 would be like, hey, did anyone send me a message? Just like I keep checking my mobile phone every 5 seconds to see if I have got the message from the one or not. So this is not actually, like, this is very expensive. So user 2 is not going to poll the gateway saying, please check if you have got any message for me. Instead, we will use XMPP protocol, which will directly send the message to user 2. But an important piece of information over here is that the user 2 will be listening to the gateway through something known as WebSockets. Okay, user 1 will also be listening through WebSockets. If you don't understand what are WebSockets, let's keep it simple. Let's say there is a TCP connection between the users and the gateway. Okay, all of the users have some way of communicating with the gateway and it is persistent since we are using a TCP protocol. Or you can create your own protocol as well if you're interested in it. But for the sake of simplicity, let's stick to TCP protocol. All the users will be listening through this TCP protocol, and what the user 1 has to do is to identify what connection the user 2 is listening on. So this is where the real beauty of chat service comes into play. The chat service will hold the information about the connections of each of the user, like what connection the user is listening to. So let's say our user 2 is listening to C2 and our user 1 is listening to C1. So we will hold all of that information in our data store, which will have user ID and connection ID. So what the user 1 has to do is to identify the connection ID of the user 2 to which it wants to send the message. But it definitely can't do that. So that will be the task of the chat service. Chat service will get the user ID of user 2 and it will query swipe service to let them know that whether the user 1 has matched with user 2 or not. Once they get a positive response that okay, user 1 and user 2 have matched, it will query the database to identify the connection ID and then transfer the message to user 2 through the connection ID to which it is listening. So this is the entire flow of the chat service. User 1 will send the message to user 2 using the user ID, which the chat service will query from the swipe service to identify if they matched or not. Once it realizes that okay, they both have matched, it will query the database to get the connection ID to which user 2 is listening and then send the message or queue the message to the connection to which user 2 is listening, and then the user 2 can keep polling from the connection to which it is listening. This is all about the chat service design. Now let's move to the most crucial part which I want to emphasize from a really long time, which is the beauty of dating applications. It's the recommendation service. Now let's move on to the recommendation service. Recommendation service can also be called search service because in front of the screens when you are doing right swipe and left swipe, what the system actually does is that it searches for the profiles in its data store which you are most likely to right swipe on. So we can also call it search service if we want to. It's also shorter to write. The search logic is actually influenced by the user preferences. If you remember, when you created the profile, you added some user preferences, age, gender orientation, location, and so on. So all of these user preferences are going to influence our search service or the recommendation model in some way. There are two categories in which we can distribute our preferences: hard preferences and soft preferences. What do I mean by hard preferences is that let's say I have set a constraint of age preference to be 20 to 24. So I really don't want to see any profile outside this age range. Okay, it's going to be really bad user experience if I see a profile of age 26 or 18 or so on, because that's what I'm not looking for. So age is a hard preference. Location is definitely a hard preference because let's say I have set a location preference to be 10 kilometers because of some reason, because petrol is costlier now, I don't know. But I have set up some preference based on the location. So I really don't want to see any profile outside of my location preference. So location is another hard preference. And lastly, gender orientation. Let's say I have set a gender orientation for female. Just imagine my user experience if I was shown a male profile. It's not healthy and I would definitely want to uninstall the application at that particular moment. So I think these are the hard preferences: age, location, gender orientation, and so on. I don't think there are any other hard preferences. Talking about the soft preferences, which don't actually influence what profile should be shown, but rather how they should be ranked. For example, what my interests are. Let's say I'm interested in trekking. So I don't mind if someone doesn't have that particular interest, but definitely if someone has an interest in trekking, that profile should be shown on top of the other profiles. What are my hobbies? What are my interests? What is my career path right now? Let's say I'm a software engineer. So I don't really mind looking at the profiles of people who are not software engineers, but if they are a software engineer, then it can really influence our recommendation model. So there are a lot of other soft preferences. We'll not go into detail in each one of them, but the important thing to remember for the recommendation model is that hard preferences filter which profiles should not be shown at all, and the soft preferences are responsible for the ranking of the profiles that are shown to you. So how are we actually going to use these hard preferences to filter the profiles that should definitely not be shown to us? One of the ways is that I can query a SQL database, and there I can put where conditions, where gender orientation equal to female, where age equal to 22 or 23 or 24 and so on. But this will be very expensive. For example, imagine for the location, you will need to compute the distance between your location and the location of the other user and then take a call if that profile should be shown to you or not. So this is not a good practice. Another way in which you can do this is through indexes. You can create index on each of these hard preferences, age, location, gender, and so on. But one thing which people forget is that when you have multiple indexes, the query is optimized only for one of them. Let's say you have created an index on age. So using the hierarchical structure of a tree, you will filter out all the profiles which are out of your age range preference. But what about location and gender? Once you have got those profiles, you really need to perform those calculations on your own to extract the profiles matching your gender orientation and your location preferences. So this is again a costly operation, because your query optimizer, you can tell your query optimizer that, hey, optimize for this particular hard preferences for this particular dimensions, and it is up to your database to decide which index it should actually search for. So that is a little bit out of your control. You cannot, it's not flexible enough for a developer to decide which index the search will actually be performed on. To get rid of this issue, we can use a distributed NoSQL database, something like Cassandra or DynamoDB by AWS or something like that. Now let's say I'm not very comfortable using a distributed file system, a distributed database, or possibly I have a preference, orientation, I'm more comfortable towards a SQL database, then we have an alternative for that as well. We can use a SQL approach with a concept known as geo-sharding, sharding based on locations. Now let's take a stop to understand what sharding actually means. So what does sharding mean? Sharding means that we distribute the data based on the values in a column. Let's say we have a column named username. So we will distribute the values from, for example, A to M, then what comes after M? N, okay, N to S, and then T to Z. So let's say we have partitioned our database into these 3 different shards. So all of these 3 different shards will have one node which will respond to it. Let's say this is node 1, this responds to node 2, and this responds to node 3. For example, let's say someone is searching for Anshul. So they only need to identify which shard they should be calling. They will be calling node 1, and hence our data store will be divided in such a way that all the user profiles having their names in the range A to M will respond to node 1. All the names which are in the range of N to S will respond to node 2, and all the names which are in the range T to Z will respond to node 3. So this is one way of sharding where we used username to shard our data. But what happens if node 1 crashes? Will we stop responding the user profiles which are in the range A to M? This will be a horrible user experience, because I don't want someone to search me and not return my profile. We can use a concept known as master-slave architecture, wherein along with node 1, which is the master slave, we can have a slave node which is node 2. So whenever node 1, which is the master node, crashes, we can use the slave node to respond to the queries for the username in A to M. Now you will ask, what if the slave node also crashes? Okay, this is a question for you all. Let me know the probability where both the master node and the slave node crash at the same time. It's really, really low, and there is no anticipation of such an opportunity. So we will use a master-slave architecture and geo-shard our data. Now let me explain what geo-sharding would actually mean. Let's say this is the map of some location, and we will divide the entire map into grids. Now each one of this chunk, okay, all of this chunk correspond to a particular node. Let's say you are located in this particular chunk. So what you actually need to do when you are performing a search operation is that you want to return the profiles within your location preference. So you would be searching within this particular node and all of these adjacent nodes. Now, the size of each of these grids will actually vary upon what is the maximum location preference which is given by the dating application or which is given by the system. Let's say you are allowed to add a location preference of 50 kilometers, for example. I think the grid size of 1 kilometer by 1 kilometer is very helpful in that sense. You can perform a breadth first search kind of a search operation where you move from adjacent node to the next adjacent node and identify if they actually fall into the location preference which you have added. Now, when those profiles are returned to you, you can perform a filter based upon the age preference and the gender preference. Location preference is a trickier option to calculate, and that is the reason we are doing geo sharding and not age sharding or gender sharding or something like that. Now, let us consider some other use case. Let us consider the geo shards for India and US. What will be the activity of those geo shards? Let's say this is the graph for India and this is the graph of US. Now this is the time axis and this is the activity axis. So during the daytime or during a particular time, okay, let me mark them as well, India and US. So when the geo shards of India have very high traffic, the geo shards of US will have relatively low traffic, and vice versa. When the geo shards in US will be at their peak, the geo shards in India will be at their lowest traffic. So now what we can do is that we can create same geo shards, we can use the same geo shards for both India and US so that we have proper resource utilization and at no point in time does our resources remain unutilized. But now one problem will arise because of the same geo shards. For example, in European Union, you are not allowed to store the data of a user outside European Union or EU. So this will create some sort of issues if we are going to use the same geo shards for different continents, particularly EU. Experimentally, it has been found that if we randomly distribute the geo shards across different geographical locations, it gives a decent enough response rate and the resources are properly utilized. But for some special cases like EU, we cannot perform this random distribution of geo shards. Now, another use case is coming to my mind where we can still optimize. Let's create the grids again. Now let's say all of these grids don't have the same number of users. For example, this grid has 10 users, this grid has similar number of users, but when we come to this chunk, it has less number of users. For example, let me just fill up something. Okay, so what we can do is that we can actually merge all of these chunks into a single chunk and then dynamically geoshard based upon the number of users in that particular grid so that all the grids have similar number of users. Now you will ask me, what if it exceeds our location preference? But remember, irrespective of the size of the grid, they are holding similar number of users. So even if you query a bigger chunk, it is going to have around 10 users, for example, and then among those 10 users, you can perform the location calculation on your own, identify the distance and filter based upon the distance and the location preference that you have set. This concept is actually, in terms of computer science technical jargon, it is actually called quad tree. I am not going to go deep into what quad tree actually means. You can check it out, search it over the web and let me know what quad tree actually means and how you can use that data structure to optimize the dynamic geosharding feature that we discussed about. Now, these are some of the random optimizations which just floated into my mind. Let me know if you have some other optimizations or how you can optimize my optimizations as well. What data structures you can use, what algorithm can be used to tweak and optimize it further. Let's take a look at what the ER model for the recommendation service look like. We will obviously be storing the user ID and we will be storing the grid ID as well. Now, based on this grid ID, we will identify the adjacent grid IDs, perform a search over that, filter based upon the age and gender orientation, and then use some ranking models to integrate it with our interest, our hobbies, my career position, and so on. And then return those profiles to the user. I don't think I really need to draw the diagram of the recommendation service because this is the database that we are going to use with it. Let me just summarize it, how our entire Tinder or let's say dating application system architecture look like. We have a client. We already talked that the client will communicate only with the gateway service. Now, there are different services which our gateway service communicate with: chat, profile, search. I'm not going to write recommendation completely. And the last one being the swipe service. I'm not going to draw all the ER diagrams and all of them. Complete this diagram as an assignment, how each of these services will interact with each other. For example, if you remember, I talked about chat service interacting with the profile service, or the search service interacting with the profile service, and so on. Okay, oops, I revealed one interaction which I didn't mention and I was expecting you to answer that. It's okay. Let me know what the complete system architecture look like. How will each of these services interact with each other? And if you have any doubt, do let me know in the comment section and I will be happy to assist you. In the hood, behind the hood in Tinder, it actually uses Elasticsearch based upon the leucine indices for each of these hard preferences. I am not going to go deep into what Elasticsearch is, what leucine indices are, and how actually Tinder performs the recommendation system and the entire system architecture. So we all definitely know that Tinder was not developed in 40-45 minutes. The real motivation for me for this video was to make sure that you are aware about some of the important computer science fundamentals which are really used in system design. We talked about some communication protocols through networking. We talked about how we can store images either as blobs or in file system. We also talked about some concepts like geosharding and so on. I know all of this technical jargon can scare you. Make sure you do some self-study, and if you still have some doubts, put it in the comment section below. I really hope this content was very informational for all of you. If you loved this video, make sure you give it a thumbs up. Also, don't forget to subscribe to Scalar's YouTube channel and make sure you hit the bell icon so that you never miss on such amazing content in the future. In this video as well, I am going to cover the system design of one such large-scale product. Day to day for commute, we use this application on a regular basis. Yes, you guessed it right. We are going to cover the system design for Uber. Now, when I say Uber, I also mean Ola, Lyft, Careem, and all of those applications which are used to provide us cab services. Now, before we start the system design of any application, the first step is to understand the customer user journeys, which is how the customer would interact with that particular product or application. In this case, we have two different types of customers, a normal user or a rider and a driver. Let's try and understand what all different customer user journeys will be there. Now, we will refer to customer user journeys as CUJs. Let's first try to note down how a driver will behave with the application. They will first create their profile. Then they will show their availability on the application that, okay, hey, I am available to take the rides. Please give me rides if they are available in the nearby location. Next, they have an option to accept or reject the ride whenever they get a notification that, okay, some user in the nearby location is asking for a cab service. So, accept or reject a ride. Now, when they reject the ride, they are back to square zero and the same flow repeats over and over again. But now, if they have accepted the location, they will be able to navigate to the location, that is the pickup location of the particular user. So navigate to pickup location. Now once they have navigated to the pickup location, they are given an option to start the ride. They have accepted the ride. Now they will start the ride as soon as the person gives the OTP or any such authentication mechanism. So start the ride. As soon as they start the ride, the user would have mentioned some pickup location and some drop location. So the navigation towards the drop location begins after the ride has started. So navigate to drop location. Once they have navigated to the drop location, the driver can end the ride and accept the payment. Now optionally we can also give them the facility to rate the particular rider as well, and the same facility will be provided to the rider as well to rate the driver. Now this is an optional requirement, we can add it if we want to. Let's try to see what all are the customer user journeys for a rider. Same thing, they will also create their profile. Now based on the location of the rider, it will show them what all cabs are there in the nearby. Like if you have opened the Uber application, whenever you open the application based on your current location, it will show some cabs which are available in the vicinity. So show cabs nearby. Now I will be given an option to put in the start location and the end location for the cab service. So add start/end location. Now based on the start and end location that I have put in, I will be shown the estimated time required to reach the location, which is the end location. And I will also be shown the approximate price of whatever the cab service is going to be. You know, it's not the exact price, but it also gives an estimation that, okay, if Uber Moto, it's this particular price, Uber Auto, it's this price, and so on. So it gives an estimation of what the price could be. More likely the price is going to remain the same, but depending upon the traffic condition, or maybe the driver needed to change the route because of any obstruction, the price may increase or decrease. So show ETA and approximate price. Now once it shows the approximate ETA and the price for the cab service, what the application will do is it will start finding the cabs for the particular person. So book cab is one user journey for that. Like right now we have not started to book the cab, we are just seeing what all prices are there, what all timing it's going to take, and so on. So book cab from the start location to the end location is the next user journey, and then the remaining user journeys are on the part of the driver. So once the driver accepts the ride, the driver will navigate to the user, and the user will sit in the cab, the driver will start the trip, the driver himself or herself is going to navigate to the end location and then drop the user. Lastly, the user is going to make the payment and rate the driver. So that is also an optional requirement, but let's add make payment over here. So now these are the customer user journeys on the side of both driver and the rider. Now one important or one customer journey which we have not added in the typical flow is the ability to see the past trips or the payment history. So that is something we can add over here as well. Let's just change the color. So see past trips. Now this can be done on the side of both rider and the driver. And similarly, you can see your current trip as well, because a lot of time it happens that, okay, 10 minutes the driver is going to come in and we keep on looking at the trip status, or we keep on looking at the current trip. So we can either look at the past trips, get a particular trip, like if we want to get information of a particular past trip also, we can get information about a past trip. So get a past trip or get current trip status. Now the benefit of understanding all of these customer user journeys is that each of these customer user journeys get translated into a functional requirement. Like these are the functionalities that the app should provide. Now we have understood some of the functional requirements. Now when I talk about customer user journeys or functional requirements, I mean one and the same thing. All the customer user journeys are going to be mapped to some sort of a functional requirement. Now let's take a look at some non-functional requirements as well. When I say non-functional requirements, which I have covered in detail in Twitter system design as well, what I mean by non-functional requirements. Now this doesn't typically affect the customer user journey, but it affects the user experience. For example, if it takes a lot of time for you to check the current trip status, then it's a bad user experience. So that is a part of non-functional requirements, that the latency should be as minimal as possible and so on. So let's take a note of some of these non-functional requirements as well. Now we talked about the first non-functional requirements, which is minimal latency. Now when I talk about minimal latency, it's not that I want super low latency like that which is required for high frequency trading firms. I am fine with some sort of a delay. Some of the services, for example, if I'm making a payment, it's fine if it takes a bit of time for the payment to get through, or if I want to check some of the past trips, it's okay if it takes some time to show me the list of past trips as well. But some of the customer user journeys should have as less latency as possible. Now the next one would be highly available. Now it is not possible to imagine if Uber is down in a city like Bangalore or Mumbai or Delhi and so on. So it needs to be as available as possible, and I'm just talking about India over here. In US and all the countries around India as well, it is very, very important that services like Uber stay highly available 24/7. So highly available is an important non-functional requirement. Now the next one would be durable. When I say durable, I mean the data should persist forever. For example, let's say that a driver is taking 10 trips in a day, and at the end of the day, the entire trip record for the day is vanished altogether. Or for example, if I have made a payment to the driver and it still shows that okay, the payment is not done through even after 3 to 4 days, that payment history is gone altogether. So such an experience is not expected from applications like Uber. The data should persist forever, be it trip history, be it location data of the driver, or be it the payment history or anything at all. The information should be durable in the database. Now the next one will be, it should be highly scalable. Highly scalable because every day there are some peak hours and non-peak hours. So if the system is not able to scale to the peak hours, for example 9 AM in the morning or 5 PM, 5 to 7 PM in the evening, then the user experience will be really bad. And if we want to add the service to new cities, to more tier 2 cities, tier 3 cities and so on, the application should easily be able to scale to such an extent that we are able to cover almost all the cities of the world. So it should be highly scalable as well. And lastly, it should be highly consistent, or let me put it into better technical words, it should be strongly consistent. Now you must be wondering that we want our service to be highly available as well, and we also want it to be strongly consistent. Now CAP theorem says that one service cannot be highly available and strongly consistent both at the same time. Now that is absolutely true, but here's a catch in this. We don't want the same features or same set of microservices to be both highly available and strongly consistent. For example, if there is a cab finder service, we want it to be highly available. We don't want that to go down at all. But for example, if there is a trip service or a payment service where I want to check some of the past payments, or if the payment has gone through or not, we don't want that to be strongly consistent. We are fine with eventual consistency for such microservices. It's alright if I made the payment through and it takes 5 minutes, 10 minutes for the payment to get reflected in my application. But on the other hand, let's say I have booked a cab and some driver has accepted that particular ride. I cannot accept the experience where other drivers are still being shown that okay, this person is still asking for a cab. So in such situations, strong consistency is really required. And also, for example, if I start the trip and it still doesn't show that the trip has started on the driver's application, then that's also a really bad user experience. So all of these things, some of these features need to be strongly consistent, whereas some features we are fine with eventual consistency. So the set of features which are highly available and strongly consistent. They are mutually exclusive and they don't overlap. So this is the set of non-functional requirements which our application must be having. Now from the non-functional requirements, let's try and understand the scale at which an application like Uber works. Okay, let's just crunch some numbers so that we have an understanding of what the read QPS can be, what the write QPS can be, and so on. So first of all, like I am following the data which was published by Uber's blog, Uber's website itself. So it's a public data and I'm not making the numbers up. Now, it was seen that there are almost 100 million monthly active users. 100 million MAU, which is monthly active users, which means that over the duration of 30-31 days, there are almost 100 million active users. So on a daily basis, you can expect to have around 10 million rides. So there are 10 million rides daily, rides per day. Now we will try and compute the QPS based on the number of rides in a day. Let's just wait for a second for this particular thing. And another number, like all across the globe, we can expect around 1 million drivers to be active on a daily basis. Since there are 10 million rides in a day, we can assume that one driver typically has 5 to 10 rides in a day. So ideally there would be 1 million drivers active on a day-to-day basis. Now when we say 10 million rides in a day, what does it mean? Per second, how many rides are getting booked or how many rides are getting requested? Let's do some computation for the same. Now in a day there are 86,400 seconds. Now I am going to assume this to be 1 lakh seconds just for the sake of computational ease. So now 10 raised to 7 million rides divided by 10 raised to 5. Now this is almost equal to 100 rides getting requested or booked per second. Now this is a huge load because behind the scenes, whenever a cab is booked, a lot goes behind the scene. A radius is created around the user's location and the application tries to identify what all cars are there or what all cabs are there in that particular location. Pings are sent to all those drivers in that particular radius and then a ride is booked. So 100 QPS is our load, operational load, and we will cover some of these aspects like what is the purpose of having 1 million drivers in a day or 100 million monthly active users. We'll try and understand how it is going to influence the system design of Uber when I'm going to talk about some of the important tech concepts. Now let's get started with some of the tech concepts which I feel are really crucial in order to understand the overall system design of Uber, starting with the most basic one. Like how is the driver and the rider being able to communicate with the Uber servers? So I'll just create a superficial diagram of this. Now when I say rider or user, I mean one and the same thing, so I might use these terms interchangeably during the course of the video. Now ideally both the driver and rider are going to communicate with each other only via the server. Now there are two ways of communication. The first one is the synchronous way of communication using HTTP request. So what does HTTP request mean? You send a request for some data and you receive a response in return. So the first one is HTTP means of communication or HTTP protocol as we popularly know it as. So you send a request and you receive some response in return. Now let's say, for example, the rider wants to request a cab from the Uber application. So it sends an HTTP request to the server saying that, hey, I am at this particular latitude and longitude, or I am at this particular location. Please send me an Uber. Now when I say book an Uber for me, I mean Uber Go, Auto, Moto or anything at all. We are not going to differentiate between these different modes of cab services. We are going to treat them as the same thing. If we want to include different types of cab services possible on an application, it's a plug and play thing. It's not a big deal for the purpose of this system design video. So we are not going to treat them as a different thing. When I say Uber or a cab service, I mean one and the same thing. All right. So now the server knows, now the application knows that, hey, I want to book a cab for this particular rider located at a particular location. Now, how does it communicate with the drivers? Does it send all the drivers an HTTP request requesting for their particular location? Like the server would ping all the drivers and ask them that, okay, let me know what your locations are, and then based on the locations and the nearby vicinity, it will send the possibility or suggestion for a cab request to those few drivers only. This is one way in which we can perform the communication between the driver and the server, but as we know, this is an inefficient way of communication. The other way of communication is using WebSocket servers. Now, what does WebSocket servers mean? When we create a WebSocket server, it creates an open connection between two clients. Now, in HTTP, there is a concept of client and server. Whereas when we talk about WebSocket connections or socket connections, there is a P2P connection, peer-to-peer. There is no discrimination between client or the server. So this is a P2P connection. Both the peers can send each other messages asynchronously. So HTTP was a synchronous way of communication, and WebSocket connection is a peer-to-peer or a asynchronous way of connection. So this is asynchronous and HTTP is synchronous. Now, using the WebSocket servers, what the drivers can do is they can keep on sending the location pings to the server on a regular basis. It can be every 4 seconds, 5 seconds or 10 seconds. It depends on what write QPS is sufficient for our particular use case. So now let's try and understand how the WebSocket connection is created. So let's consider a server sitting over here and a user sitting at the other end. Now, when I say user here, I mean both the driver and the rider. I don't mind discriminating between them as well. So this is a socket connection created between them. So let's say whenever a driver becomes available, it sends a ping to the server saying, hey, I am available. And then it immediately creates a WebSocket connection between the server and the client. So the server knows that, okay, this is some connection ID. We will also have a connection ID. And this connection ID corresponds to this particular user ID. Now this user can be a driver as well as a rider. So now the server knows the link between a connection ID and a user ID as well. Now for the user only knows what connection ID it needs to put the message on. As soon as the message is put on that particular connection, it travels to the server and identifies what the request is or what the message is. It can be both a request and a message. A message can be just a location ping for some driver that, hey, I am at this particular location. Whereas a request can be, I am accepting a ride or I am rejecting a ride. So in this way, the WebSocket servers make the communication between two different clients or two different peers efficient. So for the use case of an Uber application, we are going to use WebSocket servers, which is going to establish a connection between the riders and the server as well as the driver and the server, so that the messages keep on transmitting between all the parties. Now we understood how the communication in an Uber-like system behaves. Now let's move on to the next technical concepts and see how we can find cabs nearby a user who is requesting for a cab service. So now let's just create a table for the location data based on which we are going to find the nearby cab drivers. So there is going to be some sort of an ID related to the driver, and we are going to store both the latitudes and longitudes. Now in between, I just might shift from latitude longitude to XY axis. So I really hope you try and understand that by XY also I mean the latitude longitude thing. So now let's assume we have a table in which we are storing the latest location data of the drivers. I'm going to explain in detail how we are going to do that as well. But for the time being, hypothetically, let's assume we have some sort of a database, a fast retrieval database from which we can access the latitudes and longitudes of the drivers. Now we know for a case that there are 1 million active drivers in a day. Okay. So at any moment when we are going to find the nearby drivers, we can assume that estimation to be correct as well. So let's say this is the map of the world. Okay, I'm just going to draw a rectangular diagram, and this is the map of the world, and the user is located at some point over here. So now ideally we want to find the drivers in a nearby radius of a few kilometers, 1 kilometer to 5 kilometers and so on. So what the naive way, the most trivial way in which we can do this is by iterating through all the, like this entire table, location table. We can iterate through the entire location table and try to identify the drivers who are near me. Now another important thing to keep in mind is that we were having a QPS of 100 for cab search. So now if the QPS is 100 and we are going to traverse through the entire table of 1 million drivers, it is not going to be efficient. So one way in which we can get some improvement in the performance is by creating index over latitude or longitude. We obviously cannot create a primary index on both of these dimensions. So let's say we create a primary index on latitude. So for example, now over here we can assume that the latitude and longitude is x and y. Okay, so nearby the x latitude we want x minus 2 to x plus 2. This is the range in which we want to find the drivers. Now even after we have optimized based on one particular index, it is going to be a lot more inefficient because there could be, in some cases, there could be a lot of drivers in a particular range of latitude or longitude as well. Another way to get more optimization, to try and improve the efficiency even further, is by creating two different databases with a primary index. In one table we can have a primary index on latitudes, and on one table we can have a primary index on longitude. Now based on those primary indices, we can find all the drivers who are in that range of latitude and in that range of longitude. So ideally we will find a pool of drivers which belong to this particular latitude range, and we will find some drivers belonging to this pool of longitude range. Now after finding those drivers, we need to find the intersection between both the sets. Now this too, with a QPS as high as 100, it's going to be very inefficient. So we need a way in which we can convert this two-dimensional data into one-dimensional data. So for this purpose, I covered some of those topics when we discussed the system design video for Tinder. So do go and take a look. I'm going to mention some of the ways in which we can perform this particular thing, wherein we convert the two-dimensional data to 1D data, one-dimensional data. Now the first such way is by using geohash. I'm not going to cover in detail what geohash means, but basically the entire world's map is divided into chunks, and each of this chunk corresponds to some particular geohash. Now another way to do this particular thing is using quad trees. Now quad trees is also something which I talked about in Tinder's system design video, and if you want me to cover this in detail, then I can also prepare a system design video on Google Maps system design. Like, you can add it in the comment section if you want me to prepare a system design video for Google Maps as well, where I can cover all of these topics in much more detail. Now what Uber actually uses in its backend for the map service in order to identify where a particular driver is, or in order to find the ETA between two different points, and also for the navigation purpose, it's the Google S2 library. Now what Google S2 library does is also similar to, somewhat similar to what geohashing and quad tree does. It divides the entire spherical globe, which is sort of a three-dimensional data, into chunks. Now over here I have, just for the sake of clarity, for the ease of explanation, I have just created a rectangular map, and I have distributed the entire map into smaller chunks. So now each of these chunks is some form of a one-dimensional data. We can just name each of these chunks, we can just order each of these chunks. For example, this can be chunk, the ID of the chunk can be 1, this is 2, 3, 4, 5, 6 and so on. So in this way we have categorized the entire spherical data into one-dimensional data. So we converted the two-dimensional data, which was causing us an issue during the driver fetch, by converting into one-dimensional data. Now whenever a user is pinging from a particular location, okay, we know the latitude and longitude of the user. Now each of the latitude and longitude is going to be part of some particular chunk. Let's say it's part of chunk 5. Okay, so now we ideally want to find the drivers who are in that particular chunk or in the chunks nearby it. So now this is the responsibility of the map service, that hey, given this latitude and longitude, let me know what chunk does the user belong to. Now this user can be both rider and the driver. So when we put in the latitude and longitude to the map service, it tells us that okay, this particular user belongs to chunk 5, and then what the map service does is, based on a user's location, it will create a radius around the user's location. It can be a 2-kilometer radius which will have a 4-kilometer diameter, or any XYZ particular radius. Okay, now based on this radius, it will cover a set of some chunks. We will get what all chunks are part of the subset in which we want to find the drivers from. So over here we can see that chunk IDs 1 to 9 is the search space wherein we want to find the riders, wherein we want to find the drivers, my bad. So ideally we will also have a service which will store that in a particular chunk C, what all drivers are there. So we can directly communicate with those drivers and send them a ping that hey, a user is requesting for this service, do you want to accept the ride or not. So in this way, we just find what chunk does the user belong to, and based on the nearby chunks, we send the ping to the drivers who are in the vicinity of the user. Now what we have done is we have isolated the maps microservice which is responsible for converting the pair of latitude and longitude or the XY dimensions into the chunk ID. So let's keep making a note of what each of the microservices are doing. So map service, it's going to convert a pair of latitude and longitude to chunk ID. Now this map service itself has dissected the entire map into different chunks. So based on the chunk ID of the user, it can identify what all different chunks are there nearby. And we talked about some service. Let's keep it a question mark service over here. We will name it ahead, like I will talk about that service in detail in the coming section. So now what this does is it has a mapping from chunk ID to the set of drivers who belong to that particular chunk. Now ideally using that map service, what we have done is we have reduced the search space of the drivers to whom we want to send the pings, that hey, there is a user, do you want to accept the ride for that particular user or not. So now let's try and understand what all different things the map service can do. First of all, the ETA computation. Let me also create the map of a city to explain it in a better way. Now this is just a map of some city. I am going to divide the map into smaller chunks, which is what the map service or the Google S2 service is going to do. Now these are the chunks. Let's say the user belongs to this location, and Google S2 service, Google S2 library is going to create a radius around it to find what all chunks the other drivers are in. Now let's say we found some drivers in the nearby chunks. There is a driver located over here, 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 here and here. Okay, we found out 4 drivers in the nearby chunks based on the radius that we set and the user's location. Now we want to find the ETA, that okay, given a start point and an end point, what is the ETA for, first of all, what is the ETA for the driver to reach to the pickup location, and ultimately what is going to be the ETA to reach the destination. So now based on the chunk IDs, if you remember, we also had a location table which contained the latest locations of each of the drivers. So now if we have isolated 4 driver IDs or 4 user IDs who are in the probability radius, then it is easy to get the exact locations, exact latest locations of each of these 4 drivers. Now based on those locations, we have 2 choices with us. First of all is just to compute the distance, which is the Euclidean distance based on a set of 2 different points, but that might not be the ideal distance, because we know that for any in a city between point A and point B, we follow a road-like structure. So the distance is, if the aerial distance is 1 kilometer, then the actual distance might be something else altogether. So this can be a 3 kilometer road distance. So we cannot rely on the radial distance, we cannot rely on the aerial distance as well. what we'll do is we will use the map service, which is the Google Map service or any map service which is feasible for the particular application, and then based on that map service we will just let it know that okay, this is the driver location and this is the user location. We have isolated some drivers around and we have their locations. Let us know what the ETA is for the driver to reach the user. Now based on that we will just compute what the distance might be for each of the drivers and what the ETA will be for the driver to pick the user up. Now that is added to the ETA for the pickup location to the drop location. So in this way we can compute the ETA. Now this ETA, or ultimately what we are doing is we are finding the distance, probabilistic distance, and the time taken to cover that distance. Now both of these things can be passed on to the payment service, which will then calculate what can be the estimated price for that particular ride. So in this way, in collaboration with the map service, we will get the locations using the location service. We will use the payment service as well to compute the ETA and also to compute the estimated or approximate price. Now let's see, for example, if a driver is moving, the driver will keep on sending the location pings to the server. So how is it going to affect the flow? For example, the driver is situated in chunk 1, for example. All right. Now let's say the driver is moving in the right direction. So at some point the driver is going to change the chunk ID, or he or she is going to change the chunk in the map. Okay. So let's say this chunk is chunk 2. Now on a regular basis the updated location pings of the driver are sent to the server, and what the server will do is that it will use the map service, and inside the map service the Google S2 library will let us know that okay, this is the latest location, and as per the latest location either the chunk ID has changed or it has not changed. And if the chunk ID has changed, let's say for example it was 1 earlier and it changed to 2. If you remember, we had a question mark service, right? So that question mark service, it will have that okay, earlier the chunk ID had driver D1, but now since the chunk has changed, we will get rid of the driver 1 from chunk ID 1 and then we will move the driver to chunk ID. Now let's say the chunk ID earlier was 1, and then based on the location change we got to know from the map service that okay, now based on the latest latitude and longitude pair the chunk ID is 2. So ideally, if you remember, there was a question mark service. Okay, let me name it right now. It can be the dispatch service or the cab finder service. Let's call it the cab finder service because it keeps the note of what all drivers are belonging to a particular chunk ID. So earlier driver D1 belonged to chunk ID 1, and as soon as the location changed based on the information we retrieved from the map service, we will remove D1 from chunk ID 1 and then it will add it to chunk ID 2. Now we will understand the cab finder service in a lot more detail, but this is what I wanted to explain, that okay, this is how the user or the driver keeps on sending the location pings to the server. Based on the location pings that we are getting from the driver, the map service will identify that okay, this is the chunk ID which it belongs to. So now let's start categorizing what all different services we have discussed till now. First one is the map service. The map service is responsible for converting the lat long to the chunks it belongs to. It also performs the calculations from point A to point B, that okay, this can be the potential route, this can be the approximate time taken to reach the destination, this is the approximate price which will be required for the cab service. So these all things are done by the map service. Now we kept on talking about receiving the location pings, so let's try and cover the location service in detail as well. So the location service is responsible for all the location data related to the user as well as the driver. Like user, I mean the rider. So let's say there is a driver, and let's continue this discussion only for the driver because the driver is continuously going to send the location pings to the server. And what the server will do, what the location service will do is that it will store the latest data into the table. Now we will have a table as we discussed earlier, which will contain the driver ID or the user ID, and it will also contain the lat and long of the particular driver. Along with this, we also want the entire history of the location pings that the driver or the user has been sending to us. Why do we need it? We potentially might be needing it because we want to perform some machine learning thing, or we want to perform some analysis on top of it. Let's say a trip has ended and the rider has challenged that, okay, the driver took a bad route and that is the reason why the price has increased and I don't accept this particular price or this particular fare. So what the application will do in the backend is that it will check the entire location history and identify if this was the optimal route suggested by the map service or not. And then based on it, it will retrace the entire trip and identify if there was any mishappening which happened during the particular trip. So there are a lot of use cases, and for the safety, we are going to store the entire location data for both the users and the driver. Now, naturally, if we are going to store the latitude, longitude and the user ID, let's do some calculations to see how much data is it going to store. So for the user ID, it is going to be 8 bytes, 64-bit. Now for latitude and longitude also, let us assume it's going to be 3 bytes itself. So one row for one driver, it's going to consume 24 bytes, or for the ease, let's consider it 25 bytes for the computational ease. Now there are 1 million drivers who are active every day. So the entire capacity of the table is going to be 25 times 1 million bytes. Now this is going to be 25,000 kilobytes, and which is equivalent to 25 megabytes. Now 25 MB is quite small as compared to what all resource capacities we have nowadays. So this entire table can be stored in a Redis cluster in the form of a cache so that the retrieval is fast. Whereas when we talk about the entire location history of any user, it's going to consume a lot more data, and this data is going to grow along with time. So it doesn't make sense to store it in the form of a SQL database. So that data is going to be stored in a NoSQL cluster or a Cassandra database. So we have two things. The location service is going to hold the latest location data, and we are also going to store the historical location data. Now this is going to be stored in a Redis cluster for quicker access whenever we require it, like the map service can require quicker access to the latest location of XYZ drivers. So location service will transmit that data to the map service or any other service which requires the location data. So location service is the source of truth. Whatever location we require for any user, they are going to ask the location service that, hey, this is the user ID, can you share me the latest location, or can you share me the historical location for this user? Now this is going to be stored in Cassandra. Now I hope it made sense why the table size motivated us to use a Redis cluster, and it also helped us to get faster access to the location data. Now let us just beautify this entire system design diagram for the ease of understanding, and then we'll talk in detail about the cab finder service. We started from the map service, we went down to how we are receiving the locations in the location service. Now we'll take one step back once again and try and understand when a user requests for a cab, what the entire flow looks like. So first of all, let me just make a better diagram. Now we know that the user communicates with the server through a WebSocket. So this is a WebSocket server, and in front of the WebSocket server we will have a layer of load balancing. Now why do we need load balancers? Because as we notice, there are 100 million monthly active users, and since these users are a lot, we are receiving 100 QPS of traffic from each of these users. So ideally we would want to balance the traffic amongst the WebSocket servers. So it's not just one WebSocket server. There is going to be a WebSocket manager who is going to handle all the traffic. The WebSocket manager will know that, okay, this particular connection ID belongs to this user ID, and this connection ID is catered by a particular WebSocket server. So we will have a layer of WebSocket servers. It's a distributed layer, and then behind this layer we will have a routing service. Now what this routing service will do is, based on the request, it will distribute the traffic between different services. We talked about map service. If there are constant pings of location data coming in, then it will go to the location service. If a user is requesting for a cab, it will go to the cab finder service, and so on. So right now we talked about map service, we talked about the location service, And now let's discuss in detail about the cap finder service. Now ideally what the cap finder service does is that it matches the demand created by the user and considers the supply of the drivers in that particular radius or among different chunks. So it tries to match the supply with the demand. So some people might also call it a dispatch optimizer or the dispatch service or the supply demand service. So I'm going to use more simpler terms and put it as cap finder service. Now let's go in detail and understand what the cap finder service is and how does it cater a request of a user requesting for a cab. Cap finder service. So whenever a request will come, it will look something like this. I have this user ID. This is my latitude. This is my longitude. Go and perform the magic, right? So now this cap finder service calls the map service to identify what chunk it belongs to. Now the cap finder service looks something like a hash ring. I will explain in detail what the hash ring means as well. But to put it into simpler words, there is a distributed service where there are multiple servers. Each of this server is responsible for a set of chunk IDs. Okay, it doesn't matter what chunk ID is. For example, this is server 1, server 2, server 3, 4 and 5. Ideally, the number of chunks across the globe is going to be in the range of millions if not billions, and I'm not sure, like it's going to be in the nearby order itself, but for the sake of clarity, let's just assume that the number of chunks is just 10 so that I can explain in detail what the cap finder service looks like. So each of these servers are associated with a set of chunk IDs. Now server 1 might be responsible for 1 and 2, 3, 4, 5, 6, 7, 8 and 9, 10. Okay, we have assigned the responsibility to each of these servers, and there is also a server optimizer or a manager of a sorts who is going to take control over what request is going to be sent to the server. Now this particular service leverages the benefits from consistent hashing. Now what consistent hashing means is, for example, we want to scale this service up because the number of chunk IDs increased. For example, let's say this is a chunk ID 5 and all of a sudden you can say around 5 PM to 7 PM the traffic inside this chunk increased. So ideally what the Google S2 service will do is it will break the chunk into multiple other chunks so as the traffic inside each of the chunks is almost in the similar range. We don't want bias to be there in any of the chunk IDs. So ideally chunk ID 5 will get converted to something like 11, 12, 13 and 14. I'm just giving it random numbers. But what happened is chunk ID 5 went off and instead of it 11, 12, 13 and 14 came in. Okay, probably we will leave the chunk ID 5 where it is and we will just replace it with 14. So the number of chunks increased and the responsibility for a particular server will also increase. For example, earlier it was the responsibility of server 3 to cater to the traffic belonging to the chunk ID 5. Now with the increase in the servers, it might be allocated to any of these servers. For example, we might assign the responsibility of 11, 12 and 13 in any random particular order. So what consistent hashing does is whenever the scale increases, it is easier to add servers. Whenever the scale decreases, we can just get rid of some servers because a bunch of chunk IDs might be merged into one. Okay. So hash ring has a structure of a ring, like that is the reason why we call it a hash ring. And it has some nodes on top of it. 1, 2, 11, 3, 4, 12, 5, 6, 13, 7, 8, 9 and 10. Now the entire concept of hash ring is in such a way that whatever chunks or whatever items are there before a particular server, it will cater traffic for that particular chunks. For example, between S5 and S1 there are 3 chunk IDs. So ideally it will be the responsibility for S1 to cater the traffic in those particular chunks, and the same like 3, 4 and 12 are there between S1 and S2. So S2 will be responsible for that. Now for example, let's say we want to get rid of some chunks and ideally we will remove one of the servers. Okay, for example, we just removed S5. Okay, so what will happen, the hash ring will remain as it is. Now ideally S1, which earlier had only 1, 2 and 11, it will now also cater traffic for 9 and 10. So just by the removal of a particular server, it doesn't require a lot of changes. It obviously doesn't affect what happens to S4, S3 and S2. They can remain as they were, and the server manager which we talked about earlier, they are notified that okay, now S1 is also catering the traffic for 9 and 10. Now there is another protocol which is used for this particular matching algorithm or cap finder service, which is known as gossip protocol. So whenever the responsibilities of any of the server changes, it will just gossip to the other servers that okay, now I have got more responsibility for chunk ID 9 and 10 as well. So if there are any requests for the particular chunk ID, do assign it to me. For example, in the earlier, let me just get rid of some of the clutter over here. So for example, if we receive a request from a user belonging to chunk ID 6, okay, so what the cap finder service do is, first of all, it will identify which server is catering to that particular chunk ID. So over here, it will identify that okay, S3 is catering to chunk ID 6. Now it will communicate with the map service and identify what all chunks are nearby the chunk 6. Now in our case, I'm not sure what all different chunks are there, but let's just take an example and let's just call them random numbers 3, 7 and 12. So what S3 will do is that through the gossip protocol, it will know that okay, 3 belongs to S2, 3 belongs to S2, now 7 belongs to S4 and 12 also belongs to S2. So it will send request to both S2 and S4 that okay, I am server 3 and I want the data that what all drivers belong to 3 and 12. So S2 will get a ping that give me the list of driver who belong to 3 and 12. S4 will get a ping that give me the list of drivers belonging to chunk 7. And then based on all the drivers, we will send the pings to each one of these drivers that there is a request for a cap service. Do you want to accept it or not? So in this way, the cap finder service finds the drivers who are in the vicinity and sends them the pings through WebSocket Manager. So let's move on to the next concepts. I hope it is clear what the Google Maps or the map service does, what the location service does, and now we have also covered what the cap finder service does. Now we have covered 3 major services which are going to be part of our Uber application: the map service, the location service and the cap finder service. Now let's have a check at the functional requirements to see what all functional requirements we are yet to implement. I think one important chunk which is missing is the trip service. We haven't yet stored the information related to a trip, when the trip is accepted, when the trip is started and when the trip ends. We also haven't checked at the payment service. So let's just make a note of what all services are remaining. Create profile is remaining for both the drivers. I think that is very self-explanatory. Like we will have a profile service which will expose some of the CRUD APIs like create a profile, update profile, get profile and delete profile. So I'm not going to explain that in detail. The profile service will take care of that. Now show availability for the driver. It is exposed to the WebSocket server that whenever the availability is live, it will start sending pings to the location service. Now show cabs nearby is done. Start and end location, show ETA, book cab. So we have almost covered 2 to 4. Book a cab is also done. Payment service is remaining. Rating the driver can also be done through the profile service itself. So for that we are not going to expose a different API. Like for rating we will expose a different API, but we are not going to have a rating service just to rate the driver or the user. So this rate the driver is also done. One thing we are remaining is the trip service and possibly a payment service as well. All the navigation portion related to the driver is going to be handled by the map service. and start ride and end ride, that is going to be handled by the trip service. So let's just go and understand what the trip service and the payment service will look like. I think this is empty. We can take use of this particular page. So whenever a trip is accepted, we can just have a trip service first of all. We will have the entire chunk of WebSocket servers, and we will have a load balancer, routing service, and so on. And ultimately, we will have some trips location, trip service, my bad. So whenever a ride is accepted by the driver, a new trip will be created and added to the trips database or trips table. We are not sure, we will discuss that, how we want to go ahead with it. But let's just look back at the numbers. We were having 10 million rides in a day, and there are 24 hours. So ideally we had 100 QPS, or 100 rides were getting created almost every second. So we can divide the trip service, the database of the trip service, into two parts. One which is going to store all the inactive trips or the completed trips. They can be rejected trips as well. They can be completed trips as well. Now that database is going to keep on increasing with time. That is never going to stay the same or saturate down the lane in future. So ideally, as we discussed related to the location service as well, we would want that data to be stored in a Cassandra cluster or NoSQL cluster, because it's going to grow on and on as the time increases. So we'll have a Cassandra cluster which will store the data for all the inactive trips. For the active trips, let's make a calculation how many active trips can be during any time. So 100 QPS is there. In 1 hour, we can assume that one trip lasts for 1 hour approximately, or 100 minutes, just to make the calculations a bit quicker. So approximately 100 QPS is converted into 100 minutes, and in each minute there are 60 seconds. So ideally this is going to be in the range of 6 into 10 raised to 5. So this data can be stored in a SQL cluster because it has a higher probability of getting retrieved by the user on an active basis. So we would ideally want the read latency for that particular information as less as possible. Most likely the Cassandra service is going to get retrieved whenever we ask for some past trips or some payment information that will be covered by the payment service. But we will have a live corpus of a SQL database, and we'll store the information for all the live trips in SQL. And what we can do is we can also have a trip archiver or a cron job. This is an archiver. What this archiver will do is every 6 hours or every some X hours, it will run a cron job which will transfer the inactive trips from the SQL database or the Redis cluster to the Cassandra cluster. So in this way, the entire trip service can be configured. Now going to the payment service also, it is quite self-explanatory. It's not as complicated as the location service or the map service or the cab finder service. Whenever a trip ends, which is also notified by the trip service, whenever a trip ends, it will send a notification to the payment service to make the calculations of what amount is going to be there for that particular ride based on the distance covered. Now this trip service will have the entire ping of location data both from the user as well as the driver. Why do we need both of them when they are sitting in the same cab? In some cases, there can be fraudulent charges raised by the user to the driver, that the driver dropped the user in between. So we can configure or we can manage all of those challenges or all of those complaints by having the entire history of location pings during the course of a trip for both the user and the driver. So the trip service data is going to be quite heavy because we are going to send location pings every few seconds from both the users. So the trip service will have the location data, it will have the start location, end location, start time, end time, and all the information which is necessary for a particular trip. Whenever the trip ends, we will also have a trip status: accepted, started, and ended. These three can be the trip status. Whenever the trip ends, it will send a ping to the payment service saying that, hey, this trip ID has ended. Based on the location data, calculate the kilometers traveled. Based on the start time and end time, calculate the time taken. And based on all of these information, find out what will be the price of the cab. So payment service is also almost a trivial one. I mean, not as trivial as the profile service, but this is also a trivial one. And we'll configure the payments based on this particular service. Now, if we look at the entire diagram, So over here we have added 3 more services if I'm not wrong. One is the trip service, one is the payment service. Now this payment service will also be configured with a payment gateway. It can be Stripe, it can be Razorpay or any other payment gateway feasible for the application. And lastly, the profile service. Now let us try and cover some of the ad hoc technical concepts. Let us try and cover some other ad hoc technical concepts. For example, whenever you are in a mall, you must have seen this a lot of times. Instead of a particular pickup location, there is a preferred access point. Let's say this is a campus. Okay, let me cover the example of my hostel itself. Like I was in IIIT Hyderabad, and let's say this is the map. Now there were multiple access points for the cab drivers. There was boys hostel over here. There was girls hostel somewhere here. This was the main entry gate. And this was the academics block. Now at each of these 4 locations, there were preferred access points given. Now how does Uber compute them? Now if you notice, whenever you start a ride or end a ride, we have a location ping associated with it. Now based on the aggregations of this location point over a historical time period, now it can be over a few days, it can be over a few months, we will realize that okay, these are few of the preferred access point inside the campus boundary, and then the proper nomenclature will be done for all of them, that this is the entry gate, this is the academic block pickup, this is the boys hostel, and this is the girls hostel, and so on. So based on the aggregated data, if you remember, we stored all the location data along with us, and we were confused what all different things we could do with that location data. So we can perform some sort of machine learning aggregation on top of it. We will store all the data which is present in the Cassandra clusters. It can be the trip service, it can be the location data, and so on. We will pass it to the Kafka queues, and that will be consumed by different services. It can be consumed by the machine learning fraud services. I will talk about that also. It can be consumed by the Spark Storm service as well, which will perform some analytics on top of the data that we have given. For example, the preferred access point is one such service. And then it can be consumed by map service as well. For example, if the traffic is increasing or decreasing, it can lead to price surging as well. So all of these different niche concepts related to a cab service application, this can be done on top of the data that we are storing inside our different services. So in this way, preferred access point can also be covered. Now, for example, when we are finding the potential drivers who we are going to send the pings for in order to book a cab, it is also a possibility. Let me first show you what I mean. So here's the user denoted by the red cross, and we have some drivers who are waiting for the cab service. Now there can be one such driver who is going to end their trip at a particular location near the user. So ideally we would want this particular driver who is about to complete his or her trip in a nearby location to also be considered in the potential candidates for the drivers who we can send the pings. So all of this data is done on top of machine learning, and all the data that we are storing with the trip service. The trip service knows that okay, the trip is about to end, the trip with this particular trip ID and the driver ID is about to end. So we can also send the ping to this particular driver that hey, your trip is about to end, do you want to accept a new ride or not? So there is a lot of things going on behind the scene when we are searching for the drivers to book cab, when we are routing through a particular city, and so on. A lot of things are done in batch mode as well after the trip has ended. For example, the preferred access point was one such thing. Now I also talked about a machine learning fraud mechanism. For example, a lot of drivers do this thing. There is some sort of an incentive. Let's say if a driver completes 10 trips, he or she is going to get 1000 rupees extra. So if the driver has just completed 9 trips, they can just book a ride with another mobile phone of theirs, and they can then complete the ride just to get that additional incentive. So all of that payments data, all the location pings that we are having, all of these data is aggregated and then used to detect any fraud if possible. So now we covered a lot of topics, lot of technical concepts which are important for the overall understanding of Uber's system design. So let's just go through them once again. So these are the 6 services that we talked about: map service, location service, cab finder service, profile service, payment service, and trip service. We know the responsibilities of each of these services. Let's once go through the APIs which each of these services will cater to as well. Now these APIs, I didn't cover them in detail because it felt a bit trivial after I explained all of those technical concepts and what are the responsibilities of each of these services. So I think you can just pause the video at this moment just to have a look at the different APIs. Now one important thing which I want to highlight for this particular APIs part is that, let's say I want to delete a profile. Okay, over here I am just sending the user ID of the profile which I want to delete. I cannot delete the profile of some other user ID. That is quite an intuitive thing. So how does the service know that, okay, the user ID which I have mentioned and my user ID, both of them belong to the same person or belong to the same profile? So ideally for each of these services, all of these services, there is some additional context that we are going to pass along with it, and that can be in the form of user token or some sort of an API key on top of this. So we can have a user token. Now both the drivers and the users can have this user token in order to authenticate themselves, that if you want to get a trip with this particular user ID and trip ID, the user ID should belong to you. So we can use a user token or some sort of an API key. So I deliberately missed this particular part out from this API slide so that you get an idea of authentication mechanism as well along with this. So whenever a user is logged into an application, there will be some token or API key created against them. And this is going to persist over a longer time as well. If it's an API key, the user token will get generated every time the application is opened. Now this is the entity relationship diagram. What all tables can we store in our database? We already talked about the location table, which is going to persist all the information. We have the trips table. As we talked about the start location, end location, we have the status as well. We have the location ID, which is associated with the locations table, and it's a repeated entity. You know, every 4 seconds or every 5 seconds some location ping will come and will keep adding that location data to the trips table. Now we covered all the different services. We covered fraud detection as well. We covered maps machine learning as well, and driver profiling as well. Like based on the fraud detection results and based on the ratings that people have given, the users have given to the driver profiling can be changed. Now all of the data can be transmitted live through the Kafka queues, or they can be asynchronously passed in batch mode. Along with this, just for the sake of completeness, all of these services are emitting some logs. Okay, this can be error logs, this can be just debugging logs as well. Now all of these logs are consumed by Kafka queue, and then on top of the Elasticsearch logstash Kibana ELK, on top of this particular service ELK service, Elasticsearch logstash Kibana, we can perform log analysis and create some visualizations as well, that okay, what was the availability, what went wrong at particular time, and lots of important graphs related to monitoring and alerting can be created on top of it. So I think this is a good part to end the particular video. Like, we have covered a lot of services, we have talked about a lot of technical concepts as well. We have talked about some machine learning concepts also, which can applied on top of the information that is transmitted from the different services. I really hope you enjoyed watching through this video where we talked about some of the most important technical concepts related to an Uber-like large-scale application. If you found this content insightful, make sure you give it a thumbs up, add your opinions and query in the comment section below, and lastly, don't forget to subscribe to Scalar's YouTube channel, and don't forget to hit the bell icon so that you never miss out on insightful content.
Hey, hi, this is Arnav, and in this video, we are going to be covering a low-level design problem, which is actually a very popular problem to solve both in terms of interviews and also just as a LLD practice case study, very common, which is designing a tic-tac-toe as a game. Something probably as simple as this might not come in a real interview, might be a little more complex, what actual interview low level design problem statements might be. But this is a good place to start off from, to get an understanding of how game kind of things are designed. And there are a lot of game system design questions that come in interviews, for example snake and ladder or a Wordle game, things like that. So quickly, let's start by understanding the problem statement first, and then we will go on to actually write the code for this. So the problem statement is that we have to design a command line based 3x3 grid tic-tac-toe game that can be played by 2 players. So it depends on how the problem statement is given to you. In this particular problem statement that I am showing here, the problem statement itself specifies that the board, the numbers of the boxes should be A1, A2, A3, B1, B2, B3, and C1, C2, C3. Sometimes this might not be specified, and it's up to you to decide whether you want to number the boxes as 1, 2, 3, 4, 5, 6, 7, 8, 9, or by 1, 1, 1, 2, 1, 3, like that. Is a 2x2 matrix kind of a setup. But in this case, we have been said that we should number the board like this. The game should have 2 players. Every player by default has the character X and O, which is crosses and O's for tic-tac-toe, but player should be able to pick their own character if they want to as well. So if somebody wants to go with, say, an emoji instead of X, right, they should be able to do that. And both players must not have the same character. That's something that you have to add into the logic of the game, and every player has a name as well. Then there's the game. So the logic of the game is that the game starts with player 1 inserting the character on one of the boxes, and players get alternative turns. Some additional complexity that is possible here is maybe, if you're facing this in an interview, somebody can say that, okay, add a toss facility in the beginning which randomly decides whether 1 or 2 player will get it. In this case, player 1 will always start. Players will get alternative turns. On every turn, you ask on the command line which input box that the player wants to insert their character into. And after every turn, we show the state of the game, basically show the state of the board at this stage. And along with that, we are supposed to do one of these things. So we need to do is, like, if player specifies the wrong box, then the player gets to try again. If the player selects the correct box, in that case, this move itself might end up winning the game. So either do that, or the player does not win the game yet, the game will continue. Or maybe it is that this is the 9th move. So if it is the 9th move, then the game ends and it's a draw. So handle all these cases. Winning condition, as happens in a tic-tac-toe, is that the same symbol in one row, same symbol in a column, or same symbol in a diagonal. Okay. The data format for the game is also given in this case. Sometimes it's given, sometimes it's not. Here it's saying that to initialize the game, we have to do something like this: enter player 1 name, and then enter player 2 character. By default is X. Enter player 2 name, enter player 2 character. By default is 0. I think this should be player 1 here. A little bit of a mistake there in the problem statement. Then the gameplay is, it will always show the board first. This is the state of the board. Then enter player 1's move. Player 1 adds a move to A1. So player 1's character gets added to here. Player 2 enter box. Player 2 goes for A2, and so on. That's how it will go. Some expectations are given to us. So make sure you have a working and demonstrable code. Make sure the code is functionally correct. Code should be modular readable. Separation of concern should be addressed. General stuff in mostly all things that are given. Do not write everything in a single file. Separate out your code base. Code should easily accommodate new requirements with minimal changes. Write unit tests wherever applicable. That's an important thing. We will have to write unit tests, and optionally some requirements are that if we have time left, keep the code extensible to change the size of the grid. Keep the code extensible to allow different types of pieces. Keep the code extensible to allow more than 2 players or pieces or types. Okay. So apparently these things, if possible, we have to do that as well. So let's first try and see how to code the minimum requirements, and then we will see how we can maybe add the optional requirements to the game as well. Okay. Okay, so before we start coding the solution for our tic-tac-toe problem, just a quick note on the setup. So I'm doing it using TypeScript for this video. So just a simple idea about, I have the TypeScript compiler and Jest installed for running the tests, TS node, so that I can execute my TypeScript files. And we have got a src folder where we have the main file where we will write our code, the test folder where we will write our tests, the package.json file which has the start script which runs ts node. That's all. Most of these setup is usually not going to be important in a interview kind of a setup, because generally you have a hacker rank or some online id inside which you will write the code where the setup is sort of done for whatever language you're going to be picking. But this is just to set up a base line from where we will start with. Okay. Usually you are not allowed to install any libraries as such. So the only thing libraries that I actually have installed here is Jest for testing and TypeScript for compiling the code, the TypeScript code. That's all. You should usually not have anything other than that. Anyway, so to get started with, I would actually make a new directory for the entities. We would need basically 3 entities here. We would need a board file, we would need game, and a player. Okay. Okay. So essentially a board should need, I mean, all of these would be classes. Okay. So class game, this would be class player, and this would be class board. Okay. So essentially we would have like the game would need a board and a player inside it. So and then we will run the game from main. So we will start a new game, something in the sort of game g equal to new game, and then game dot start. That's all we will have on our main file. Okay, so that's sort of how we will set up our project. Tests is to be able to run tests for our board, our game, a player, and then so on and so forth. Okay. So let's get started with the basic stuff that we will need. So for the player, we need, obviously we have found out that we need a name and, sorry, and we need a character. Okay. What we can do is we can pass all of these two things inside a constructor. That when we construct a player, we pass a name and a character. We can also do a builder pattern kind of a thing as well. So what we can do is player dot builder, right? We can do a builder pattern so that we build a player, set name, set character, right, like that. Okay. For now, we can construct the player using a name and a character. Default character, as we have seen, is going to be X and O that we will handle inside the game class. For example, we can do that. Okay. Board needs to have sort of the grid itself. So we can actually have grid, which will be an array of an array of, we can actually do an array of a string here. Equal to, and we can actually write this itself. So we can do something like this. Okay. So 3 of these. So technically the board looks like this. Okay. So that's the grid. We will have to specify a way to print the board. So let's, and then inside the game, we will need to start the game, initialize the game. Okay. So that's sort of how our entities would look like. Let's get down into actually detailing out, obviously, the entities, right? So character, by default, we will create one. So game, what we will have is we will have P1 of type player. We'll have P2 also of type player. Okay. We will have to export these, by the way, and you have to export the board as well, and we'll have to export the game as well. Yeah. So player has to be imported. Yeah. And we will have the board. Okay. Got it. Now, if we have to create a builder kind of class, how do we handle that? So we can create a builder pattern for the player, and we can create a builder pattern for the game. The board did not have a builder pattern because we can straight up create a board and it has the grid at its initial situation already. Okay. So if we do here, basically, I think we don't need a export here. Actually, so we don't actually have a, inner class kind of a pattern that exists in Java. So what we can do is we can basically have a player builder itself. So you can do like a player builder, okay, which should have a name and a character. It should have a constructor which has neither of these things. Okay, sorry, it should not have anything here. So we will do is um, create a setter for these two. Okay, and return this from both. Okay. Got it. Then we will have a build function. So we'll have a build function that returns a player type basically. Okay, and return new player where we pass this dot name and this dot character. Okay. In fact, yeah. We can make the constructor sort of private if you want to, like module private or something like that, which we do in Java. Here TypeScript does not really matter. We do it like this. So we have a player builder. Okay. So in game, when we sort of initialize the game, we will have to build the players basically, right? So that's one of the first things that we'll do. So game should also have a game builder essentially. Okay. So we will have a okay. As the game builder, we will set the player 1, set the player 2, and initialize the board. That's all that we need to do in the game builder. Okay. One of the main things about the player builder still is that we should not allow, if we have a builder pattern, then we should not allow somebody else to be able to build the player automatically. So one thing what we can do is we can do something like this. We can write static builder equal to, and maybe we can use the class player builder actually directly there. Okay. If we do this, then we can make the constructor as private, which would mean that in main.ts we can't write const p equal to new player. This is gonna be invalid because this is gonna be private. But what we can do is we can do pb equal to new player dot builder, and then we can do pb dot set name and then dot set character and then dot build. So this is gonna be possible. In fact, we can actually try this out. So set name, let's say my name, and then set character. Maybe my character is, let's say this, and build. So console.log pb dot, not pb, const p equal to. So now we can do p dot name and p dot character, right? So this, if I just sort of want to run, I think the start script should do it, is yeah, Arnav and emoji that has sort of been built. Okay. If we want to, so that becomes my player builder pattern. Okay. Then sort of we can do something similar with our game as well, right? So what we can do is we can do static builder is class game builder. Okay. Now we will obviously have finally the build class. So we will have a build function that returns a game object, and we will do, so we can do a private construct. So we can do like basically a private constructor of all the 3 props, and this can create this. Okay. In terms of board, we can allow directly board creation because directly grid is there. So what we can do is here in sort of the build function, return new game, but to return a new game we need a p1 player, a p2 player. Okay, so what we need here is p1 character. Okay, or we can just do this thing. We can have p1 and p2 as players inside here as well. So we're going to create player 1, right? Inside create player 1, we have to read the value of the basically name of the player and character of the player, which we can default to X. Okay. So create player 1 P1 equal to new player dot builder dot set name. Sorry, set name would be this dot set character would be character and build. Okay, this dot p1 equal to this. So I will do something similar with creating the player 2. This dot p2 would be in similar fashion. Okay, and then we will create a new game where we will pass p1, this dot p1, then this dot p2 and new board. Okay, that's how we will build a game. But we will have to have some process here, is that if p1, if this dot p1, sorry, if not this dot p1, okay, throw new, you have to create a new error here. Create player 1 before creating game, or you need to create player 1 first. And similarly, if p2 does not exist, then you need to create player 2 before building game. Okay, so now we have a good situation here, is that when we want to create sort of the game itself. So if I do let's say const game builder equal to new game dot builder, right? When I do that, then if I do gb dot build, okay, straight away what will happen, I will get an exception. Get an exception that you need to create player 1 before building game. So I will have to do gb dot create player 1, give a name, right? And sorry, that's player 2. I have to return this from within here in each of these. Okay, so then dot create player 1. Let's say num1 is player 1, I don't know, it's player 2, like this. Now if I run it sort of works. Okay, this will not work if I don't have any of these lines here. If I don't have player 2, it will also fail, again with the exception that we need. Okay, so we have a mechanism to build the game, build the player. Now we have to start adding all of the logic inside our board layer and the game layer. So the game needs to have the logic of moving to the next turn and asking for inputs and all of that. So essentially, our main thing, what we will really do is we will create a game using the game builder and start the game. Okay, so game.start, something like that, which will do every turn one by one. So game will have the driver code, which is called the game driver, and the board would have sort of the logic for selecting each kind of variable. Okay, so let's go and try to build that. Okay, next what we'll do is let's start adding some of the methods on the board logic. So with the board logic, what we need to do is we will do a few things, like we'll have a print board function that can print the board, and we will do like marking different spots in the board by a player. So let's start doing that. Okay, so of course we can have just print board. Okay, print board should be pretty simple. We just go ahead and print sort of console.log, and we print the board. What do we print here is we can do this dot grid 0 0, and we can have basically this. Okay, if we want to be extensible, we should do a row wise printing thing here. Actually, we should do print row 1, print row 2, print row 3, like that. We should so I'll just I mean, this is sort of hard coded. It's not extensible code actually here, printing it like this. Okay. So probably like actually iterating through the grids is kind of better. I will write, you can actually write some code here that this grid can be made extensible, like board size. Okay. So we can have actually something like const board size equal to maybe 3, something like this if you have like at the here. Now you can do like make it board size based, so that extensibility I'm not building actually right now. If we do that, that's sort of better. So we will cover that towards the end and see how it can turn extensible. But anyway, so 0, this will be sorry, yeah, so this would be 1, this and this would be 2, this and this would be 2, and this and this would be 1. Okay, so that's sort of print board. Mark board, and inside mark board, if I do basically okay, so the box would be box A1 or B2, like that, and character would be the character that the player is marking. Okay, so to mark the board, we will have to obviously check a few things. So first of all, if box dot length not equal to 2, throw an error, invalid box identifier. Okay, then what happens is const row equal to, or something like box dot caret 0, right? And or we can do something like this, const row equal to a b c dot index of box caret 0, and const call equal to box dot caret 1. Okay, so then what we will do is, if grid this dot grid row call, not if this equal to already underscore, in that case we can write throw error, or we can return a boolean here. Okay, and what we can do is in this case return false. We could not mark the board because that grid is already taken up. Okay, so this is the mark board function. Else what we do, this dot call equal to whatever character we are marking the board with. Okay, return true. Okay, so just to sort of try this part of the board out, we can try it on the main actually. So what we can do is const board equal to new board, sorry, right? I call print board, board dot print board. Okay, then I do board dot mark, let's say A1 with this character X. Okay, and then do board dot print board. So let's see how this looks like. Okay, this did not work. So print board worked, but marking A1 at X and still print board did not work. So let's see why that did not happen. We can do is, oh sorry, so if it is not marked as underscore actually, so then we return as false. Okay, so yeah, this marking happens. One important thing is now we realize that in our game, we cannot allow people to have underscore as a character. So we can add that error here in player. So this dot character. If value, we can do throw new error. Okay. So we can't allow underscore as a valid player character. So mark board. This. Okay. Cool. So that's how mark board looks like. Then if we want to sort of see get row as string, okay, which returns a string. So if you want to do that, okay. So what we want to do is if we pass row A, B, or C as a string, right? So row, we can do this same thing, const row equal to okay, and then we can return this dot grid of that particular row, and we can join it with an empty string. Okay, so this gives us certain things like board dot get row as string of row A. It will show this row itself. This is useful to find out who has won or not. Okay, so let's see, get row as string. We can do a get call as string as well. Okay, so we can take this one as a number actually. Okay, so we will basically do return, and we'll create an array of this dot grid row 0 of this particular column. Okay, we will through our inspection kind of things. So if call less than 0 or call greater than 2, we can have a throw new error here, 0 and 2, right? We can do something like this here as well. So if row name not equal to A, B, C, we can do A, or we can do something like this. If ABC dot index of this thing, basically if ABC dot index of row name -1, then row has to be A, B, or C, like this. Okay, so get row as a string, get call as a string, that returns our column as a string. We can print column number 1 here. Console.log board.get column as a string. Which column? I want column number 1 actually. That should print x underscore underscore. Sorry. Yeah, so this works. Okay. So we have got the row as a string, column as a string, and we can obviously so we can have two diagonals, diagonal 1 and 2. So if diag number equal to 1, we can do this. Else if diag number equal to 2, we can do another thing, and else we can do error. Okay, so diagonal number 1 is gonna be technically 0 0 1 1 and 2 2, and diagonal number 2 would be 0 2 1 1 and 2 0. Okay, so if diagonal number 1 is this, then return. If diagonal number 2 is this, then return. Else throw new error, invalid diagonal. Okay, so get row as string, get column as string, get diagonal as string. We can print those values, which is useful to check if somebody has won in the board already or not. Okay, so on the board we don't really need anything else. We need to be able to print the board, we need to be able to mark the board, we need to be able to get rows, columns, and diagonals as strings. Okay, in the game code now, we will have to write the sort of driver code, which is basically play each turn, who has the current turn, check whether victory is there or not. Okay, so that's what we will do next. Okay, let's see now how our game code might look like. Okay, so we build a player, create player 1. I think we should do is add player 1 and add player 2. I think that should be better sort of names. Add player 1, add player 2. Anyway, so we do this. Okay, so this is to build a game. This is sort of done. This is the constructor. We need to also have this value called turn. Okay, so let's say we have turn equal to 0 initially. Okay, turn equal to 1 initially maybe, or we can do 0 as well. Okay, so let's say we have a function called play. So while turn less than 9. Okay, so we will do certain things, of course. When we reach like turn becomes 9 basically, right? So this is a draw condition. Okay, or we actually have, sorry, so if turn equal to 9, so with play, what we will do is we will take the box as string. Okay, so play box as string, whose turn it is. So player would be basically turn this dot turn modulo 2 equal to 0. In that case, p1, or in the other case, p2. Okay. Sorry, yeah. So this dot p1 or this dot p2. Okay. So this will be our player. Okay. Now, what we have to do is we check board dot mark board, the given box. Okay, with the character of player dot character. Okay, so we do is const success equal to this dot board dot mark board. Okay, now sorry, so if not success, okay, or rather I would say if success, then we do is we do turn plus plus, and turn should then not be a const, of course. So we do this dot turn plus plus, so turn increases, and if this dot turn becomes 9, then game should end. So basically here what we would have is game ended in a draw. Okay, Now, if success, then we do turn plus plus. Else we don't need to do anything. We will just have to play again. Okay. So to play, what we will do. So if it has been successful, then we also have to check that whether, so we will also have a game state. So what we can do is type game state equal to started, won, draw. Okay. End winner, and we have end draw. Okay. So initially we will have game state. Okay, like this. So initially we have game state is started. Okay. We will change it to winner or draw. So if turn is 9, then state equal to end with draw. This dot and a straw. Okay. Now we have success. Then we need to check whether no this was a winning move or not. Okay. So we can have a function private check winner. Okay. Now this winner would usually only be basically the current player who has turned, that is the player who can win. Obviously no other player, like the other player can't win in current turn. So if I am playing this turn, then after I have put something, then I can only be possibly the player. Okay. So check winner whether it's player is of type player and with the board. So what we have to do is player dot character. Okay. Const winning line equal to, basically winning line would be right. So this would be the winning line basically being the characters 3 times. Okay. So we will check basically A, B, C dot for each. We can do so rows dot for each. What we can do is board dot get row as string r if this is same as winning line, or we can do is for let row in A, B, C if this dot board dot get row as string equal to winning line, then return true. Then for let call in 0 1 2, similar thing. If board dot get call as string in the call, then return true. Get call as string, are we taking call as number? We are taking call as number, right? So okay. Okay. Oh, we have to use off here. I'm sorry. So with the let call of 0, 1, 2, we do this, and then finally we do something similar for the diagonals as well. Okay. Else we return false. Okay. So do the check winner thing. So if check winner with this current player, then this dot state equal to winner console.log game over, and we will write the player who has won. So the player who has won would be game over, player has won. Okay. Then we can directly, I mean, we don't need to do the turn plus plus technically anymore. We can just return from here. Otherwise we do turn plus plus. If turn becomes 9, then we can say we have ended in a draw, game has ended. Okay. And we check for the success. Okay. We can create a function for the prompt as well. So we can do is the next turn prompt. So we can do is next turn prompt can be a string which says that this dot turn, I think we can do +1 actually, turn number, or we can start from 0. That's, I don't know, it depends on the user use case. We want to show it from 0 or something other. This dot turn +1, and we can do so we can do the same thing here. Player dot name, and then we can do inside brackets maybe player dot character. Okay. So this prints the next turn prompt, and then we return as play, and then we keep continuing like this. So what we can do in the main section now is we can do something like this. I'll remove all of these things. What we need to do is we need to build the game, of course. So const game builder equal to new game dot builder. Okay. Player one name equal to, and this is where we will need to read data from the console a little bit actually. Okay, so what we will do is we'll use this import star as RL from, so we'll use this module called readline sync. What it does is we can do things like RL dot question, sorry, RL dot question, and we can pass a question here, enter player one name like this. Okay. So what we do, player one name, player one character, player two name, and player two character. So enter player one name, player one, we will say by default it's going to be X. Okay. And player two name would be player one name. So in question, I think we can pass some options. Options, maybe I think we can have a default input. So we can do like this question, this default input is actually X for this, and here default input is actually for this. Okay. So then what we will do, game builder dot add player one with player one name and player one character. Okay, we'll do the same thing here. Okay, then we will do const game equal to game builder dot build. Now once game is built, we will run the game while game dot state equal to started. Till then, what we will do, const box equal to rl dot question, and inside question I will pass game dot next turn prompt, and then whatever we get in the box we do game dot play that box. Okay, most likely this should work. Let's see how does it look like. So enter player one name, let's say I do Joe. Player one character, let's say I put I don't know, I put some J here. Okay, player 2 name, and I put player 2 name as Paul, and player 2 character P. So turn 1 player 1, what do we enter here actually, right? So A1, we have a problem. So here, so apparently when we're doing get diagonal as string, we are passing diagonal 1 and 2. Okay, sorry. So we are supposed to check for diagonal 1 and 2 rather than 0 and 1. Or rather I can do this and check for diagonal 0 and diagonal 1. Okay. So what we have to do here is after every turn we have to print the board as well. So I forgot doing that. So here inside game, if board is success, this dot board dot print board. Okay. Or inside main, I think I will do a little bit of difference. So I will do game dot next turn prompt like this. Okay. So now we have enter player one name Joe. Let's say we go with J. Paul. We go with P. So turn one player Joe, enter box. So I go with A2. So J here. Paul will go for B1. Okay. So like this, and then we pass A1 maybe like this, and then we will have, oh actually we need to index it up actually. So according to our problem statement, which we had A1, A2, A3. So our row numbers should move one more. So here when we add mark board box, so box dot length, so row is this, call is going to be this plus 1 actually, minus 1 technically. Okay, so number is going to be box dot character at 1 minus 1, so we will mark it accordingly. Let's play it again. So player 1, let's say we go with Joe, we give default X, we go with Paul, maybe default Y. So enter box A1, Paul would go for, let's say, B1, then A2, B2, let's say, then A3 if we go. So game over, Joe has won. I think we should print the board state for all the cases, so we can do that. Maybe what we can do is this dot print board. We can do it for all the cases, whether or not success. Okay. So we print the board, then we ask for the turn like that. For everybody we will do. Small typo here. This is by default supposed to be O. So that's pretty much it. Our basic game sort of is working at this stage. We don't need to import board. We don't need to import player. Yep. So let's start again. So player 1 name, let's say Arnav. Player 1 character, we can go with an emoji maybe. Then player 2 name, Naman, maybe another emoji. So enter box A1, enter box A3, let's say B3, B1, right? C2, C3, A2, A. If I do A1 again, if I keep doing A1, it'll have to, same player has to keep on with that turn. We need to show the error as well that, box already taken. We should do something about that. But anyway, we can go with B2 and then finally with C1. So game finish in a draw. So basic game logic sort of is working. We haven't added the tests yet. We should add the tests and all of these error conditions to be shown. We should do that as well. Okay. Okay, so let's see how to add a little bit of testing code. So to test, let's say we add one TypeScript file which will test for testboard.spec.ts add. So we write tests like this. Test, name of the test, board initialization works. Okay. Don't really need the assert done callback, I think. So this is basically to check some errors inside the done callback anyway. So what we do is we will do stuff like this. So to check for the board initialization, const b equal to new board. Okay. We have expect b dot get call as string 0 dot to equal. So we do for 0 1 2. Get row as string also. A B C same thing, and get the diagonal also. Get diagonal as string, diagonal 0 and diagonal 1 to be the same. Run the test. We need to call assert at the end. I think assert should be called with anything, I think. Yeah. As long as it is not with an error. Awesome. So board initialization works. So test board marking works. So for that, what we will do, const b equal to new board, something like this only. Then b dot mark board a1 as, let's say, k. So expect b dot get row as string a dot to equal k underscore underscore, and b should be fine. Expect b dot get call as string also 0 column to also be equal to this thing only, and finally assert. Okay, so board marking works. This works. Okay. Technically we can run all tests also. So board initialization board marking works. Okay. we should be able to run all tests with coverage as well. So when we run all tests with coverage, we will see that inside my entities and board file, there are still some lines not covered, which is we are not checking whether the marking identifier is wrong. If that's the case, we are checking that or not. If we are trying to mark a board which is already marked, we are checking for that or not. Okay, so we will have to check those as well. Mark board should be false. For that case, we should check that. Get row as string, wrong value we have not tested. Okay, so when we test for coverage, we will see that there are certain lines we have not tested, which means we only tested the successful cases, not the unsuccessful cases. So we should test for the unsuccessful cases too. So to do that, what we need to do is test. Okay, how to do this? So repeat marking returns false. So b dot markboard a1 character k const attempt 1 const attempt 2 equal to b dot markboard again a1 with any value, let's say 0. Okay, so we have to see expect attempt 1 dot to be truthy and expect attempt 2 to actually just to be true and false. Okay, so let's try this. Works fine. Okay, so we have to check that if we mark the board again with the same parameter, we get false. If we run this with coverage, we will see our coverage. Of course, if we run all tests, some coverage increases. Mark board with the false condition, this gets covered. Still don't check for whether the box name is invalid. How do we test for that? So that also has to be tested for. Okay, so we have to do const b equal to new board. Now if we do expect, actually here we will do b dot mark board on say a3. A3 is there, a4 mark with any letter, let's say G or 1. Okay, dot to throw, and we have to throw which error? Actually it should throw invalid box identifier. So level 1, expect this dot to throw, since it didn't throw. Why? Because we are not checking for number 4 here. Okay, so we have to check that if row less than 0 or row greater than 2, or call less than 0 or call greater than 2, we have to throw the same error here. Okay, if we are doing twice error like this, we can do is we can do inner class here, extends error. We can override the message equal to invalid box identifier error, and then we can do this invalid box name error. Okay, so then we can check with this, tests. Okay, apparently that didn't work. Expect this invalid box identifier at board.markboard. Okay. Okay, we have to actually create a function here instead. I think this should test correctly. Yeah. So we expect a callback function inside which we can do certain functions and expect this to throw. Okay. We can try out with a few more as well. So if I try out with A0, it should also throw. If I do A, B, C, if I do D1, this should also throw. If I do with a single letter A, that should also throw. If I do it with 3 letters, A01, they should also throw. So that's sort of correct where it checks all the possible cases. Does this test actually cover everything? Let's try all tests with coverage. We see that board.ts is still 84% covered. There are still places which are not covered. For example, the get functions are still not covered. Get row as string, get call as string, get diag as string. All of these are not covered. Okay. So we should write tests for these as well. Okay. So in fact, in the board, what happens is if I do get row as string and I pass something that's not ABC, then we should get this error. Okay. If call is wrong, I should get this error. And if diag is wrong, then I should get this error. Okay. So we need to handle that as well. So let's go for the tests. Okay, so here what we will do is expect, so we'll simply write const b equal to new board, and then we will do expect to throw. What do we need to throw? So for the row 1, b dot get row as string, and if I pass d, similarly now, if I do get call as string and I pass 5, then my error has to be call has to be between 0 and 2. And then finally, the diag one, if my diagonal is 4, then I need to get invalid diagonal. Okay, let's see, this test should also pass. Oh, I have forgotten calling assert at the end. Signify the tests I went. Now the thing is that if I run all tests now with coverage, my board would almost be covered, 96%. The only thing is we have not tested the print board function. So while this is not a functional thing, it's just a printing, we can add a test for that if we need to, if print board was returning something. Console.log functions can't really be tested. So that's test for the board. So we should then similarly have tests for our game as well, for our player as well. Okay. Player, we should just need a builder test that player can be built. Game, we need to do the entire test of the logic. Can check winner, check the prompt, check play, all of that stuff we need to check for, and we need to write tests for the same. Okay. So I'm updating all of these things. I would just add a commit for this. Tests for the board logic is done. So actually on the same repository where we had the problem statement, there we have the solutions in TypeScript as well. Okay. And here there are the test files written that I've just added the tests. The code for the board is also there. The code for the board, the game, and the players and everything. So the entire solution is also there, the same repository. So you can go there and check the code. I would actually update the code with the tests for the game and the player as well. Okay. So next question that comes, of course, is like, what are the things which are actually not extensible, which not designed well yet in this game, and we can make them extensible. We can make them better designed than what they currently are. So for that, I'll just remove the coverage right of everything. Yeah. So for example, the board, hard coded to 3. We read that, one of the things that it wanted was, the problem said that you need to make it extensible to change the size of the grid, allow different types of pieces. Different types of pieces actually we have already allowed. More than 2 is something that we have sort of not allowed yet. Okay. So how do we do those kind of things as well? So to do those kind of things, first of all, let's say, for example, the board, this grid, this format, not good. We change this to what we will do. We will have a const here, const board default size equal to 3. Okay. What we will do here is we will create a constructor for the board, and the constructor, we instead of taking the grid, actually we will not take, we will take here size number equal to board default size. So if no size is given, we will take the default size. What we will do, we will do this dot grid equal to an empty array. Then for let I equal to 0, I less than size, I plus plus. What do I do? Grid, this dot grid, and inside that we push new array of size, whatever the size is, grid size, and we fill it with underscore. Okay, that's it. So that way, and then we have to change the print board part as well. So the print board part, actually I will change it a little bit. So instead of doing a console log, we will actually return a string actually rather than print board. So there are a couple of places. There's only one place where print board is called. So we'll call it get board for display. Okay. And what we will do here is we'll do like this. Return this dot grid. So actually, we will do like this. Const display rows equal to an array. Okay. We will do for row, for let row of grid, display rows dot push this dot grid dot join with tab actually. This dot, sorry, this row dot join with a tab. Awesome. And then we will do return display rows dot join with a new line. Okay. So then wherever we had this in the game function print board, we will do, instead of this, in the next turn prompt, what do we do? This dot board dot get board for display. Get board for display. And then we have this return message. Okay, or we do this and plus /n plus, and we have this string. Okay, so we do this plus /n plus this. Okay, get board for display like this. So let's see how our board looks like now. Player one name Kate, let's say Roman, something like this. Okay, so board looks like this. Enter box A2, A3. Awesome, works, right? So that's how our board looks like now. We can add, let's say, maybe initially some this as well, so that way. So now we have some space after each as well. Okay, one part not covered is so my board can be constructed with any size now, though we don't know what's going to be the row numbers and all, etc. Okay, so what we can do is okay, so what we will do is we can maybe use all the letters. We can put the upper limit at, let's say, 26 or something like that. So up to 10, let's say 1 2 3 4 5 6 7 8 9 10. Okay, so now what we will do is we will do this. Rows dot index of. So if it is greater than 0 or greater than so we need to actually store the size of the board as well. So our board of size would be size. So this dot size equal to size. Okay, so now we will write if row is greater than this dot size, call 0 or call is greater than this dot size. Okay, similarly get row as string. So this would be rows dot index of this row has to be 1 off, and we can do here rows dot substring. We can do 0 comma this dot size. Okay, and again here we can rows dot index of row name, get call as string. So get call as string would be this dot size from here to size. We can't print it this way anymore. We will have to handle this using a for loop now. So what we will have to do is we'll have to do call vals dot push this dot grid I and call. Okay, and then we will return call vals dot join. Okay, have to do the same thing with diagonals. So if diagonal is 0, we will have to return again for loop. We will have to do basically. So right, so if this, then for let I equal to 0, I less than this dot size I plus plus, and we have to do diagvals dot push this dot grid I comma I, right? We'll have to do I and this dot size minus I for the other one. So for this one we will have to do I and this dot size minus 1 minus I. Okay, so if it is 3, then it will be 3 minus 1 2 1 0, like that, right? So then we will have to do return diagvals dot join. Here also return diagvals dot join. Okay, so we have made these changes. We haven't made any changes in the test board. Let's see if all the tests work or not. So we have to update some tests. So the tests that need to be updated is, so here what happens is that A4 invalid box identifier should have not coming, which means we will have to go to mark board and check why is it not coming. So if row is greater than or equal to, we will have to do, and call greater than or equal to, we will have to do, to run again and see. So get row as string, here also we will have to check this. So if row equal to, we'll have to do like this. Okay, so if row num, so if row num is -1 or row num greater than equal to this dot size, this dot size is supposed to be a number, right? Let me see. Sorry, row num. Yeah. Got it. Now let's see. So here there is a little bit of an issue. So because the error is not constant anymore, right? So we can't expect exactly same issue here. So what's happening here is when we are checking, this row has to be one of, this is the expected error here. So inside tooth row, of course, we will have to we can't have exactly the same string actually. So what we can do is rather than this, we can pass here something that do row number is invalid, and maybe we can, that's the same error that we can do there. Okay, this way at least we will get the errors to match. We can mark with regular expression the initial part of the error as well, but nevertheless, now you see we have done this exercise which makes our board actually, you know, on the error side. So there are a couple of things. Having these tests help us in one very important thing. As you can see, I did not change anything in the tests. But as soon as I updated my board, some of my tests started failing, which means that there were certain parts of my board's checks which were not correctly done after the extension. So that's why having tests help. And in most cases, like for example, in the test, the only thing I needed to actually change in test was this error name actually, because we are having a little bit of difficulty matching the error name. We can actually make that work correctly using error types rather than error names like this. But nevertheless, as you can see, these errors I did not change. Like these are the lines which are changed actually. These gray identifiers here, as you can see. So as you can see, there's nothing inside board that has changed. The board test that has changed. Just by updating board, we were able to run the tests and see that whether the tests are passing or not, because the test should continue to pass, because although I made my board class more extensible, the previous functionality for the hard-coded board class of 3 rows and calls should continue to work nevertheless. I mean, I have expanded the functionality, but it does not mean old functionality should stop working. So that's one of the, test, that's a validation that the test we had written was correctly written, because these tests continue to work even after I have refactored my board class logic. So my board class is now pretty extendable. I can create a board of any size that I want to. We can, in the main player, we can get any type of size of the board that we want to, but our logic in the game will not match if the size of the board is not correct actually. So we have these hard-coded logics here which will not match, and the reason they will not match is also because we don't have tests yet for the game. So because our board is now extendable, but the game is hard-coded to 3 size boards. So we need to fix these. Okay. So let's see how we can fix that as well. Or maybe you can try and fix that, send a pull request to this repository, where our code is. But for now, the board has become extendable. The game we still have to fix. Okay.
What's the first advice that I give to any candidate before they begin with their technical interview? Don't jump onto coding directly. Make sure that you explain your approach, the choice of data structures and algorithms with logical reasoning, and then only move to coding. Similarly, whenever you are starting with a project or any product development, make sure you don't jump onto it without proper planning. Now, what do I mean by proper planning? I think this video is going to be an interesting journey for you all. We are going to talk about software architecture design. What things you should be cautious about while planning your software. What things are important from a technical perspective as well as a customer's perspective, and so on. But which product should I talk about for this demonstration? I think we should choose a social media platform. And at this point, I know you have guessed it right. It's going to be Twitter, my most favorite social media platform. So we are going to go through a broad overview of designing Twitter's software architecture from scratch. Let's begin. The first part of any software architecture plan is to gather the requirements. What features should your product support? We need to understand this from different perspectives. Like, what are the pain points of the customer? What is the customer looking for? What are the wants and needs? How feasible are these features from a technical point of view? We should gather all of these requirements before jumping on to the architecture design. Understanding technical feasibility will not always be as straightforward in the beginning. You might be required to travel further down the road of designing the product. You may require to break your software architecture down into multiple layers and understand how each of the technical components in this layer interact with each other within and across the layers. Whenever you think about the requirements, consider both functional and non-functional requirements. Functional requirements are the ones which are critical for the product to be called a successful one. For example, in case of Twitter, it's going to be user should be able to create a profile, follow other profiles, tweet about something, scroll through the home or user timeline, and like a tweet, and so on. Whereas in case of non-functional requirements, it affects the user experience but not necessarily the features that are exposed to the user. For example, performance of the system, reliability or uptime of the system, and so on. I know complex products like Twitter will have a lot more features and requirements, but for the purpose of this video, let's stick to the ones that I mentioned above. Why is setting requirements so important before starting a design plan? Because most of your design will be influenced by your requirements. And once you have noted down your requirements properly, a lot of your technical options will be decided for you. That's how powerful the influence of functional requirements is. Now we'll move towards breaking the entire system into smaller components so that it's better for us to visualize them as individual systems and design them better. Earlier, when we were talking about the requirements, we were looking at an eagle's point of view. Now we'll move from a high-level design to a low-level design of Twitter's software architecture. When you move from requirements phase to planning phase, think of the system as individual layers. It can be very helpful. Think of your product as a cake. where each piece of a cake is a different feature that your product is supporting, and each layer of the cake is a different component interacting with each other in the backend. Most usually, each piece, which is a feature, will have all the layers which are the components which are interacting in the backend with each other. I hope this horizontal and vertical slicing of features and components help you understand how a product can be designed both vertically, feature by feature, or horizontally, component by component, or usually hybrid, which is the case with most of our development. There are two major components when it comes to the design of any software architecture. Number one, database design. Number two, backend interactions, how the information flows between the servers in the backend. Now, from the requirements, it's pretty clear to us that we need to leverage the functionalities of a relational SQL database because there is a relation between our users and the tweets. Whenever a new user is created, we will store that information in a new table, users table. We won't be storing the tweets in the users table. We will have a separate table to store the tweets, which will be related to the users table, where the user ID is going to be our foreign key. Now, when we talk about the follower interaction, we can easily add a list of all the followers in the users table column, but that is an inefficient design. For this purpose, we will create a new table where each column belongs to a unidirectional relationship between a profile getting followed and the profile following the other profile. At this point, we can summarize two things. There is a one-to-many relationship between the users and tweets table. A user can do multiple tweets, and there is a many-to-many relationship between the users for the followers relationship. One user can follow many users, and many users can be followed by one user. At this point, I think our database design looks fine, but we might need to revisit this design when we are discussing the serving flows. Now, let me talk about an issue so that I can highlight you what issues can come up in the future. Let's say a user is requesting for home timeline. For this purpose, we need to find out all the profiles that the user is following. Then we need to query all the tweets done by those profiles, sort them in chronological order, and then return them. Can you visualize an issue creeping up with this thing? Don't worry if you don't. I will talk about some of the important characteristics of Twitter as a product, which will help you realize what issues can come up for this serving flow. Twitter has 300 million daily active users and 6,000 tweets done every second. Also, 600,000 queries are made to fetch different timelines. This brings to light an important discovery which shows that Twitter is a read-heavy system. We are fine with eventual consistency. It's completely normal if a user is not able to see a tweet of one of the profiles eventually. Space is also not a huge constraint because all of our tweets are character limited. As we discussed in our characteristics, Twitter is a read-heavy system. So the brute force fetch operations that we are performing might not be efficient on our databases. We need something which allows us to read faster and can also scale horizontally on the fly. The first thing that comes to my mind is Redis cluster. Yes, that's how powerful the requirements are. We can't solely rely on Redis cluster, so we will be storing both the user and tweet info in the Redis cache as well as in our database for backup. With this design in mind, we can check off some of our feature requests like creating a user profile, following a user, publishing a tweet. Now, let's dig a little deeper into two of our query flows where we fetch user timeline and home timeline. Let us begin with designing our user timeline flow since that's more simpler and lesser in scope as compared to our home timeline. If you remember my previous discussion, we talked about different pieces of cake and different layers inside a cake. So currently what we are trying to do is to design a piece of cake where we'll try to leverage different pieces or layers of the cake which we have already discussed. So in order to fetch a user timeline, the first thing we need is the user ID of the timeline we want to fetch, which we can query from the users table. After we get that user ID, we will query the tweets table to get all the tweets for that particular user ID and then return it to the requesting user by sorting them in chronological order. Now, Twitter is a read-heavy system and hence querying the database for this purpose can be very cost heavy. So we will introduce a caching layer in our Redis cluster which will store all the information about the tweets that the user has made and query the information from this cache instead of querying the database, since querying from cache is faster as compared to querying from the database. Now this solution might serve sufficient for our user timeline flow. Let's move on to the home timeline. Let's say I am requesting for the home timeline. For this purpose, we would require all the profiles that I follow, which we can fetch from the followers table. After getting all those user IDs, we need to fetch all the tweets made by those users from the tweet table, merge those tweets and sort them in reverse chronological order and return to the requesting user, which is me. Now we can see an obvious drawback in this solution. This solution will be very inefficient once the size of the tweets database grows to millions of data rows. For this purpose, we need to revise our serving flows and update our design. In order to overcome this issue, we will follow a fan-out approach where we will move from a single data source to multiple data sources, one for each of our users. For this purpose, we will have an in-memory home timeline for each of the users, where the home timeline will contain the tweets by all the profiles that the user is following. Now let's say I have 10 followers. So whenever I will tweet something, this tweet will flow through the load balancer into the server and stored inside the backend, both database and the cache. Now the server will query all of my 10 followers from the followers table stored in the cache, and through the fan-out approach, we will inject this tweet into the home timeline of all of my 10 followers we fetch from the cache. Now, one issue that might come up with this approach is, let's say I have millions of followers. Now it's practically not possible to inject my tweet into millions of followers' home timeline at runtime. For this approach, we have a special solution where we will use synchronized calls along with fan-out approach. What this approach means is that for profiles who have immense amount of followers, like thousands and millions of followers, we will not inject their tweets into the home timeline of their followers. Instead, now my home timeline will only contain the tweets by the profiles that I follow and don't contain large amount of followers. So now what will happen is that my home timeline will only contain the tweets by the profiles that I follow and don't have large number of followers. Also, my followers table in the cache will store a list of profiles that I follow and have large number of followers. So during runtime, what we'll do is that we will try to send synchronous calls to all of these profiles having large number of followers and fetch their tweets and merge them with the pre-computed home timeline of the followers that I follow but don't have large number of followers. In this way, we will try to leverage both the parts where we will use the pre-computed home timeline as well as compute the tweets of the profiles that have amazing number of followers on the fly and mitigate the issue in this way. Now, there are so many other optimizations that we could deploy. Let's say, for example, there are some profiles who haven't been very active lately. So, for such profiles, we don't need to pre-compute the home timelines. There are so many other optimizations we could deploy, but for the sake of this software architecture design demonstration, we will restrict ourselves to only these ones and move ahead with other feature developments. Now, among the major requirements which we discussed earlier, the only piece of cake left to be designed is the search engine. For searching, Twitter uses Earlybird, which is a real-time inverted index based on Lucene. Whenever a tweet is posted, Earlybird will do an inverted full-text indexing operation. The tweet will be broken down into bits, words, and tags, and each of these words is stored or indexed into the distributed table, which will contain reference to all the tweets which contain that particular word. Now let's say I search for a word, for example DSA. Okay, so now we will find that word in the distributed table and return the reference to all the tweets which contain the word DSA. From this reference, we will return all the tweets belonging to that reference from the tweet table. As we recollect the earlier characteristics, we know that Twitter is read heavy. It receives tremendous amount of search queries. In order to enable fast searching capability for all the users across the globe, Twitter deploys a scattering and gathering tool. What this means is that the search query is distributed across different data centers globally, and each early bird shard is queried for that search operation. Now all the tweets returned from these individual shards are merged, re-ranked, sorted, and then returned to the user based on the popularity of that tweet. Now I feel that we have established a very solid base for our Twitter's architecture design. We have discussed about the functional requirements as well as design for some non-functional requirements, which included performance issues, scalability, and by further optimizations we resolved all of those issues. Let me share a few good tips for software architecture design. Use diagrams to visualize your concepts, different technical options you have considered, and any serving flow involved in your design. Now, when you are designing for the first time, don't try to fit your design to some pattern. Instead, focus on the high-level design, covering all the components, how they interact with each other to avoid over-engineering. Remember, your first design is just an iteration. You will move through some innumerable iterations to finally something that can be implemented. When you are designing, it's very natural to allow scope creeping by adding a lot of other requirements. Make sure that you discuss the functional and non-functional requirements with the stakeholders and are aligned with them. Software architecture design is more effective when there is stakeholder input and a proper mapping of requirements to design. Don't skip on this early planning and you will surely be rewarded with smoother project experience. I really hope this video was very insightful for you to start your first software architecture design from scratch. If you find this content interesting and insightful, do like this video, share your thoughts in the comment section below, make sure you subscribe Scalar's YouTube channel, and don't forget to hit the bell icon so that you never miss notifications for amazing content.